introduction, MC, and then pass the microphone to Darko? Yeah? And then, yeah, we'll use one microphone for MC and speaker. Yeah?
Sounds good. That's what we wanted to do.
He's a pro. Click the slides to go to Darko, and you're good to go.
Okay. Hello. Good morning, everyone. I'm Jillian, part of the go-to-market team here at causaLens, and I'm the host for today. A warm welcome to those joining us here in the heart of innovation, San Francisco, and to the thousands tuning in via live stream from over 35 countries around the world. We're thrilled to have you with us. Today, we'll explore how the world's leading organizations use AI agents and automation to revolutionize data science. From forecasting to fraud prevention, marketing to manufacturing, we'll cover it all. Throughout the day, if you have questions for our speakers, head to Slido, Slido.com, and enter event ID 2595941. We'll be taking audience questions at the end of most sessions. Now, to officially kick off the AI for Data Science Conference, please welcome Dr. Darko Matovski, founder and CEO of causaLens. Darko will share how AI agents are revolutionizing data science function from automating workflows to truly enabling autonomous decision-making.
Thank you, Gillian. Be careful. Welcome, everybody. Welcome, everybody. So great to see you. So great to see you here. Today we'll be here. Today we'll be talking a little bit about the future. Of data science, but we will also be announcing some very exciting partnerships, and we'll be also you'll have the privilege and opportunity to hear from some of our customers how they're using data science agents to transform their businesses. So today I want to tell you more about how the future of data science is going to look like. Before we start, I want you to imagine a world in which data science was free. Today, though, it's a very complex system, a manufacturing line in which your data has to travel through until it gets to value. And each part of different skill sets, different tools, and a lot of need to put those tools together, right? So data science today is extremely expensive. And we have not enough data scientists. And the very few we have spend most of their time on cleaning data. According to Gartner, about 80% of their time is spent on manipulating and cleaning data set. That's Monday, Tuesday, Wednesday, and Thursday, data cleaning. And then value maybe on Friday, before the weekend. And so if you take the average pay of a senior data scientist in the US, it's around 200 to 300K. So that means about 200K a year goes to just moving data around, trying to prepare it for data analysis. So this is the that manufacturing line that we all know. This is how it looks like today. We have raw data. We need to build some pipelines to clean the data. We need to do some modeling. We need to build some experimentation pipeline, and finally some visualization pipelines. So this is very slow and very, very costly. To make matters worse, for each part of this workflow, we have a different tool. So we have a tool to do data cleaning. We have a tool to move data from one place to another. We have machine learning platforms to build models. We have applications and systems to build visualizations like Tableau. And because this is so complex, we also need to have a lot of humans involved. We need humans to drive every tool. There is a learning curve. There's training. There's empowerment. This takes a while until you learn a new tool. And then there's a need to make all these things work in tandem. You know, when you're building the manufacturing line and you have different products, you need to figure out how to connect them. That's where, you know, system integrators, consultants can come in and help. But you have this really big ecosystem just to go from raw data to something valuable. So you have, the worst part here is that, yeah, you have tools, specialized tools, special skill sets, a lot of ramp-up time, and then a lot of integration cost to put them all together. And the worst part is, when you need to do something new, when you need to change something, say your marketing team wanted to analyze a new customer segment that you didn't have things set up for, your pipeline today, your manufacturing line can kind of break pretty easily, and you may need to kind of rebuild it all together for a slightly different use case. The other alternative is to say, hey, let's just outsource everything. Let's give it all to a system integrator or a consultancy. But that's not a solution either, because it's going to cost a lot. I was speaking to a CIO that spends $4 million for data cleaning just for one use case, and the quality of the work and the timeliness of it and the stress that it incurs that you know exerts on their team, cannot be measured with value. So really, rather than improving the manufacturing line, we're just shipping this complex manufacturing line somewhere else. And so data science is very slow, very expensive, and after all these investments, 87% of organizations still report to be at a low maturity in terms of analytics, according to Gartner. So while people have been building these very complex manufacturing lines to go from raw data to better insights, something has been happening in the background, a bit of a revolution that is changing all of this. It's possible now, for the first time, to replace all these different tools in the value chain from data to insight with a digital worker. So let's just take a moment to just to appreciate how transformative this is, right? So previously had a tool for each part of the value chain, a specialized knowledge work, so data engineer, data scientist, UX engineer, and then you had to have all these consultant systems and integrators to help you run this really complex process, right? Now, with a digital worker that can do this whole thing, you completely change that, right? So you no longer need all these different tools, all these different talents to run them, and all these different people to put them all together. So that's, as an analogy, this is what we are now able to do in data science. We're able to take, initially what was like a craftsmanship type of effort that then got automated into kind of a manufacturing line, to now, with data science agents, it's more like a 3D printer. You can just say, hey, this is what I'm trying to do. Can you manufacture for me the right set of pipelines, the right set of models, everything for me just in time. And so I want to show you guys how this looks like. We can empower business to self-serve themselves. And so this goes, in the first part of the talk, we talked a lot about the cost and the complexity, but this is the most exciting part of the most important implication is that now everybody can have their own data science team at their fingertips. So this is just a really quick demo of how you could enable anyone to maybe visualize some data and understand it without having to go to a specialized data engineer. So in this case, we're saying, hey, I have this really cool data set. I want to figure out what's going on in it. Can you do that for me? And so these agents will launch it's a multi-agent system. It launches its specialized agents. I just realized I've been standing in front of the screen all the time. So apologize for that. I should have been somewhere here, but hopefully you're able to see most of it. So you can see there, while I was just moving from one part to another, the agents created a beautiful UX, a beautiful application that helped us understand this whole data set. So here's another example. Imagine you are going to a board meeting, and the CEO says, hey, I just noticed our revenues are down by 5%. Can you tell me why? What caused this to happen? Typically, if you're not prepared, you would say, okay, sure, I'll go back, I'll do a lot of data analysis, and I'll come back to you. It's probably going to take like a couple of weeks to get the answer to this. Now imagine a different world in which, while the board meeting is ongoing, you can say, let me take care of that. Let me launch an agent. Here's all my data, macroeconomic data, everything that I have. And I'm going to ask my agent to figure that out for me. So explain to me, why did our revenue drop? Here's all my data. And so here, we're giving instructions. We're going back to the board meeting. And in this case, I think it was 20, 30 minutes of autonomous work by the agent. We'll be able to get the answer, right? So what you're seeing here is a fully autonomous agent that was able to answer this question of why did the revenues go down by 5% by taking all the data available in the enterprise, including macroeconomic data. And we get a nice executive summary. We get all the code written for us, all the assets generated. We can inspect and make sure it's trustworthy. But most importantly, we get a nice executive summary that tells us that the 5% drop was because the inflation index rose this month. So that was kind of the key insight there. But we were able to go ahead with our board meeting. The agent did all the work for us. We got a nice report and a lot of data science assets just to make sure it's done the right thing. So that was really going from 2 to 3 weeks of human time to 20 to 30 minutes of agent time. And so that looked kind of like a bit of a futuristic scenario, but I want to reassure you that this is here today and now. And what you just experienced in that demo was a multi-agentic system that did some reasoning first, understood what the user wanted to do. It then created a detailed plan. It then ran multiple experiments in parallel, and you could have actually seen all the chain of thought that it went through. It then took all the experiments, judged them for quality, combined them, and was able to produce that executive report. So a lot of really cool science happened there in the 27, 30 minutes that this agent was doing work. So what do agents mean for us, right? Well, they mean 95% reduction in time to insight. That's what we saw in that demo there. Rather than the CEO waiting 3 weeks to understand why the revenue dropped, they can get the answer straight away. We talked about this really complex manufacturing line to go from data to an insight. Well, we can reduce that cost dramatically by 80% using agents. And because we've empowered our humans with digital workers, well, now they can do 5 times more than what they were able to do before. And so these agentic systems are so powerful that they're going to transform how we do data science, and they're going to potentially put pressure on the entire ecosystem. So the ecosystem of all these different tools that are required, and then the people that are kind of operating all of these tools that may come from outside our organization. So I just we started off with a question of like what happens when data science is free and available to everybody. I want to end with an even more important question of what value will your organization create when data science is free and accessible to all. Thank you very much.
Thank you, Darko. An incredibly exciting, questions?
Yeah, if you guys have, sorry, if you guys
We do have some questions.
Ah, great.
Fantastic. First question is, it says, great to see the innovations that causaLens is bringing to data science. Well, thank you. How do you see the data science team of the future looking?
That's an awesome question, yeah. So data science teams are not going anywhere, right? Or data engineering teams, like we need as many as human data scientists as we can get our hands on, right? So the role, though, will evolve. So instead of a highly qualified, highly paid data scientist spending their time changing the color of a dashboard from red to pink, or wrangling, fighting with data all day long, we can create a more inspiring role for data scientists. So the data scientists of the future, instead of doing this boring stuff that they must do today in order to get to the fun stuff, we envisage a world in which they are primarily creating and managing an army of digital workers. So their role changes from an individual contributor to chief of staff for the digital workers. And that, I think, it's a far more exciting role than the one we have today. So that's kind of the vision that I have for the future.
Amazing, thank you. Second question, are there any parts of the data science workflow that agents can't help with?
Yeah, I mean, I think that's a question of time. I think, yeah, I guess event form of superintelligence, but I would say yeah, it's a function of time. The good news is that the 80% of the laborious grunt work that we have to do today can be done with agents. So I would start there. So like, let's liberate the humans to do the fun, exciting, innovative stuff. And currently, they can't do that because they're, fighting all these tools. If we can just do that, that's just going to make, Monday to Thursday more fun. And I think that's the starting point.
Amazing. Darky, thank you very much.
Thank you so much.
Thank you. Okay, now for our first guest talk of the day, we're thrilled to welcome Punit Gupta, Director, Data Science, Global Planning at Cisco. Punit will show us how Cisco is using Causal AI and agents to better drive demand forecasting across the enterprise, from product to individual SKUs. Welcome to the stage, Punit.
I'll check them out. So I won't make the same mistake Darko made. So where are we? Right. Okay, yeah. So I lead a team at Cisco that sits inside our global planning function in supply chain. It's the front end of the supply chain, from a planning perspective. So we sit behind the rest of the company in terms of sales and sales and product development and finance. But we are driving the signal for over 10,000 products that Cisco builds, from 10 plus business entities across all the major regions, all the major vertical markets, business to business, different routes to market as well, and then customer segments that's our selling segments, which are enterprises, public sector, service provider customers, et cetera. So it's a complex system that we're trying to forecast the demand for. And so I started 5 years back at Cisco, and I've started with a team of 4 people, and we have grown to 18 people. All right, so hopefully it's that linear-ish curve, but it's been slightly more exponential than that in the last year. I think as we build value, I think that the key is about building value. And so democratizing data science, I think that's a great concept overall. But the talk that I have is about what does it take to create value and actually revolutionize something, okay? And the science is crucial for that. Now, we could do science faster with agents. So if there's something I want to leave with you through the course of this talk, it's one thing. You got to get the science right. Ultimately, enterprises are running on people who are trying to make good decisions with the data that they have available, and the best decisions they can, of course. Okay, and most of data science is empirical improvement. It drives, I would say, at least inside the enterprise, it drives efficiency improvements largely, but the value creation is spotty, and that's the reason why a lot of data science projects fail as well, for that reason. Okay, it takes a long time. Maybe we can do it faster. But ultimately, our success that at least we've seen is around bringing causal AI into the very, very dynamical domain of forecasting. So can we bring science into a forecasting realm? I think that's the foundation of it. And then the second part of it is, in order to actually create the revolution, you can't just do a POC or a pilot or a portion of things. You actually have to do the whole shebang. So doing the whole shebang is really where the issue is. And so that's kind of what I'm going to talk about, right? So, okay. So challenges in forecasting. So I explained the problem statement we have at Cisco, and on the left-hand side of the chart, you see the demand volatility. So the year-over-year change in our demand. Going back to 2000, pretty much, doesn't look very forecastable, right? From the perspective, there have been pockets of stability, but largely it's not forecastable. And I think and then you see the actual challenge in this. The second chart on the right is the red are the actuals, and the green is a forecast that is predicting the demand for the enterprise segment of our products 1 year out. So it's trying to say, okay, what do I expect the demand to look like a year out? And you see that there is a problem in here. And this is the classic recency bias. We see it in investments. We see it everywhere. Okay, it's like we are grounded in the current and in the most recent trends. And it's very difficult for us to break away from that issue. So rather than actually go into any more gory detail, I actually asked some chatbots to describe the challenges in enterprise demand forecasting. And I got 3 answers. I picked 3 answers over here. And then I asked a reasoning model to tell us how to rank these 3. Okay, so we got this ranking criteria for this limerick that best describes the 2022 supply chain crisis. And of course, I got some very good criteria from the reasoning model. Hey, the limericks should best describe soaring demand, supply bottlenecks, enterprises struggling to adapt, or overstocked and empty shelves, right? And then it highlights in each of these limericks what the key phrases are or words are that it's using to rank things. So number 1 was, manager bold took a chance to predict with a confident glance, but the data misled, demand twisted and fled, Now they're stuck in a surplus trance, right? The interesting thing was actually what the reasoning model ranked as number 2 and number 3. So number 2 is actually pretty darn good as well. But the reasoning model said, hey, it's less specific about the outcome compared to number 1. I thought that was pretty good. Even better, okay, it was number 3. So number 3, the last sentence there is, and stocked up for chaos with glee, okay? And it was a very serious situation. I think most companies had severe repercussions. And so the reasoning model correctly said that it was too lighthearted for the gravity of the situation. I thought that's really, I think that highlights one of the biggest strengths that there is for these reasoning models to help us or to help agents, which is evaluate things in high dimensionality, right? That's, I think, the question, the part here. But anyway, I just thought this would be a good way to start things now. I'm going to go a little bit faster. I think I'm going to go, so I'm going to cover this in 2 sections. First section is about our journey and some of the things that we've learned with respect to bringing causal AI into the demand forecasting realm. And then the second part, which is primarily what everyone is here for, is around agents and where we see agents helping us. So our team, so essentially, the team was set up to provide a reference forecast and efficiency for supply chain planning. So we had product-centric, essentially the whole design was product-centric because supply chain tends to be product-centric largely. And then we had envisioned that if we do this reasonably well, we can take this long tail of SKUs away from human planners and provide some efficiency to the organization that way. So that was the initial goal. Now, we engineered, and again, this is about a 4-year period that we've been working on this, and we've partnered well with causaLens, have been a great partner for us. But we engineered this system, and I'll go through this in a second here. There's a little thing on the right here where hopefully my cursor is visible. This is the hierarchical system that we took almost 2 years data engineering and creating this hierarchical system of features that would then help enable causal modeling. So the way we broke this thing up was to build aggregated models at higher levels, and then more detailed models at lower levels of aggregation. And I'll talk to that also in a second here. But it was very successful in terms of trying to predict 1 year out demand in a very tough environment. At least looking back from a backtesting perspective, it was very successful there. So what happened is that success then bred to more use cases, and then we expanded our view to look at the broader set of problems that were there. So we said, okay, at a Cisco level, not only do we want to see a product level view, but we want to also see a regional view, and we want to see a sales segment view. So we want to see an integrated view of what the total demand for Cisco looks like. And so that's part of the expansion of our team. And then that is leading us to further opportunities as we work on solving that well. So this is how we did it. Again, just a glimpse of it. We had over 6,000 features, all kinds of factors, macroeconomic factors, internal factors, and causal AI allowed us to build a parsimonious model. This model was for this set of demand that I explained to you in the enterprise, and we trained this model just before COVID. And then we back-tested it. So the model actually came in. This is one of our oldest models, a simplistic model. In October of 22 is when we actually launched this model over here. And you can see that this was far more successful in predicting the downturn. Again, the challenge we had was nobody believed us in the beginning, right, when we came up with this. So a little bit more about the hierarchical system. So we have different levels of hierarchy. So the highest hierarchy is the business entity level. And that's where we see more of the macro and sentiment and supply features that tend to have an impact a year before. You see there's a time hierarchy as well. So there's a product hierarchy and there's a time hierarchy, and both of them are important in a causal chain. The time hierarchy is important as well. The thing I want to illustrate is that the number of models blows up on you. So if you look at it, we have about 30 models at the top level of the product hierarchy. And there are 300 models at the platform level. So these are the different groups of products that have similar features and similar customer sets that Cisco builds and sells to. And so there are about 300 there. And there are 3,000 SKUs, I think primary SKUs, that we built. Oops. So think about it this way. You've got, this is for one time hierarchy. And you want to go to multiple time hierarchies. So this number multiplies there. Also, if you look at the top level, and this is the product hierarchy that we just looked at, we have the regional hierarchy, and then we also have not the regional slices, and then we have the sales segment slices. So to make this thing meaningful, we have to actually look at all three of these at that top level over here. So just a little bit more flavor on these models. So this is the model I'd shown you before. This is for the enterprise group. It's trying to predict a year out. This is when the model was launched. When we start building models in this case, the second model here is a 6-month out model here. The first one was a year out. It was a year's offset. This is on a back test. We saw some very, very interesting things that come out. And in fact, I'll have an example at the end that references some of the features that showed up in this model. But you see that it's tighter. Now, of course, there is a model selection bias in here, but it's also a very parsimonious model that's done very well for us. However, you noticed, right, in the previous slide here, there is a period of time in the first half of calendar 24 when both these models were not doing well, okay, relatively speaking. Okay, now, I think they were 6 months back or a year back in terms of their prediction, so it's understandable from that perspective. But we still, I think we had to figure out what happened. And the thing is that when we started to look at more granularity, this is at the business entity levels, inside this group or super group of enterprise businesses, we started to see better resolution that came through. So the importance of going down to the right level of granularity, also considering in this particular case here, the supply chain crisis started out with supply constraints, and Cisco is a supplier as well, right? And so as we blew through those supply constraints and finally were able to ship products to a customer, we actually dumped it on them as well. And that dumping caused a suppression in demand, which is what we see in this section in the first half of 24. And so it took us to actually build more granular models with the right feature set, with these shipment features and other things like that, to help us actually better calibrate what occurred at that point in time. So that's kind of like our causal side of the story. The value was enough, and it was significant that it showed us that we really needed to do this across the board, and that we were able to do this, and that's what I'll talk a little bit more about. How do we build these better causal models? We leverage structural causal modeling to bring business relevance while respecting the complexity of the problem. So decomposition of time series. We have multiple forecasting approaches. We have an industrial approach for causal modeling, which is we leveraging causal graph discovery for feature selection, which is a unique thing, I think. We've had a lot of success with that, but that process takes us 2 weeks to do, to build a good one, wherever we care about. Also, there's the custom causal graphs with curated features, which is, I think, what most of the industry is trying to do in specific use cases. So either of those two take a lot of time. And in order to build a quality model, which is what unlocks the value in the company, okay, it takes time. And that's really the crux of where I want to go next in here. So what are our pain points? So we have 3 major areas of pain points. So there's model confidence. You know, when we build a model, is it considering the right features to the right level of complexity? Is it capturing the business problem well? Is there enough richness in the structure of the model? Are we missing any drivers? You know, typically, like I think, again, going back to Darko's talk, it takes time to engineer new features and bring them in, especially if we have already tapped out all the low-hanging fruit, and now it starts to get to be the more difficult features, like things that are coming out of unstructured data or data that is very unclean. So that becomes a problem. We have uncertainty in the models. How can we have more confidence when we initially build a model, given the uncertainty levels that are there, both in the features as well as in where we are? You know, economic regimes are notorious. What you train on is very different from what is happening. I think we're all seeing this in terms of our stock portfolios today. You know, it's weird, right? And so that's part of the problem, is trying to, how can we understand the true uncertainty in these models and calibrate and respond quickly to that. And of course, you know, overfitting. I mean, we have a very, very, you know, it's a very narrow set of data with a very wide set of features, and so overfitting is a serious issue. I think causal inference is probably the only way in which you can cut down the risk of this meaningfully. You use any other approach, traditional machine learning, you might as well not try. Because you're not going to get any better than anyone else. So that's one area, is model confidence. Scaling is another significant area. The search space is very large. I mean, each new business has got unique characteristics, you know, and so how do you come up with a causal graph that is, let's say, as close to the truth as possible? Very, very non-trivial. I'm not anywhere close to where Darko is in terms of being able to do this thing, you know, without serious human effort. Assisted, of course, but serious human effort. I think this is where I think there's a huge amount of opportunity for us to unlock the true potential of doing science in the enterprise. Of course, I showed you the growing number of models. I think the more success you have, that breeds more work, generally speaking. And even when you look at the problem out here, if you solve 20% of the problem, from an enterprise perspective, it can and may be able to help. But really, I think the big value is when you solve 100% of it. And so if you are to do it all and do it reasonably well, then you know, the amount of work is much more than what any, you know, reasonably sized team can do. And so I think this is another area, the major pain point. We have skill variation. The average you know, data science tenure in my team is a little bit over 4 years. Okay, so we've done this on purpose. We did it very efficiently, and I think that, you know, our relationship with causaLens enabled or democratized to some extent our ability to leverage advanced causal inference algorithms and processes to be able to do this better with that level of experience. But there's a lot of skill variation that's there, and so that's a pain point. Relevance and trust with our stakeholders. So you know, interpretability in business terms, being relative versus data science terms. That cannot be understated, right? It's like when we build models, you come up with all these crazy transformations that don't mean very much to most people. So what is it really telling you? Okay, and that's the cool thing about causal, is that it's trying to tell you something. You have to figure out what is it that it's trying to tell you, and that's not a small thing; it's a huge thing. A coherent story over time, time offsets. and then and then other adjacent opportunities. Like I talked about how we're going beyond product to the sales side. Our salespeople are selling solutions; they're not selling necessarily products. So in order to actually be able to relate with them, we have to now create a new pipeline that is starting to look at solutions, which is a very, very fuzzy problem. What is a solution? How do you cluster it? How do you define it, et cetera? So again, those are the kinds of things. In order to really drive relevance and trust, you've got to speak in the same language, and then your models have to actually talk in that language as well. And so you need the hierarchy underneath there. Going on, right? So putting ourselves in the shoes of our data scientists. This is a manufacturing line analogy here. So in the causal process that we have, so we have a pre-modeling process. Sorry. We have a pre-modeling process. And this includes EDA and creating pools of features, feature selection from thousands of features times thousands of transformations of those features. We are in a very, very massive feature set out here. How do we drill this thing down? That's a significant problem. Starting to build the structural causal models with causal discovery algorithms. Finding what is the best set of models. What is your leaderboard of models for a given forecasting problem that you've got? The interpretability. What is the model telling you? And then if it's telling you something that's not making sense, your number one on your leaderboard, could be, and again, let me back up a second here. So how do you rank your models? Today, we are using very one-dimensional, small dimensional factors like a MAPE or something like that. When you look at something that narrowly, what we're finding is most of the time, we're looking at the top 10 or top 20, and we're making our own decisions to say, no, after COVID, there's no way this model should have fit perfectly, right? So things like that. There's a lot of business context in there that goes into figuring out what actually is a good model. Are the features coherent? Is that set telling you a tightly knit, verifiable story that relates back to the business? Not easy things. And so we're spending a lot of time doing that. So that's to build a model, and then there's a recursive loop that occurs between the causal discovery, model search, and interpretability aspect of it. And then once you have the model, then there are all kinds of questions that come up. What is it saying? Why is it saying it? What happens if? And that is another very cool thing about causal is the ability to do counterfactuals if you build these models well. Okay, if you haven't, then of course you get spurious results. But if you have taken care, then you can do a lot with that. You can answer a lot of very difficult and important questions with that type of capability. So in terms of where agents can help us in here, I think everywhere is a simple answer. But I'll highlight some of the big areas. So given our skill gap, skill differences, and then the learning that is going on, every EDA for every model, we're learning something about the system, learning something about how to do it better. And so the cross-learning EDA agent, we think, is going to be a huge thing for us to be able to do a better and better and better job. Ultimately, that helps us get to the ground truth in terms of NSEM. The place where we've spent the most time is in terms of feature selection assistance. It's not quite an agent yet, but that's where we've spent a lot of time. And that helps us through a lot of that process. Same thing with the causal model discovery assistant. We've done some work in terms of trying to help us do this leaderboard. Again, it's a narrow dimensional view, and we're leveraging these assistants primarily in the longer tail so far of the models that we have. The more important ones, we do a lot less of this. It's a lot more curated. And then in terms of the model inspection, explanation, ranking, slideware, slideware is a real problem, and then scenario and counterfactual agents. That is I think, a significant area for us. So if we kind of go back to the ranking analogy, model ranking using the high dimensionality that's available to us through LLMs, through reasoning models, we are very excited about working and trying to figure that piece out and see if we can not only out the box, but also as we build our own knowledge stores intentionally to help the LLM, through RAG stores, et cetera, do that. PhD economist, that's an agent actually I'm going to show you a very brief glimpse on. So that is a part of this ranking process overall, because the story has to be coherent. Again, we're trying to whittle down from 100 plus models down to maybe 5, and do something, and then get to the best one that captures everything, and then it's going to give us the highest confidence overall. So I'll go to the model explainability agent. I'm actually going to skip through. I think I'm running a bit behind. Oops. Okay, so this is not quite working very well. So it's supposed to blow into a whole slide. Okay, I'm just going to work with this right now. So this is a simple question. I mean, nothing as complicated as what Darko was saying. What are the model predictions for net bookings in 6 months in 6 month increments from January 2022 onwards? And so it's a classic agent. It's again a very simple one, sub-agent, I guess. And then you see the chart over there. And the right-hand side, what are the drivers of these predictions? So this is basically coming from our 6 month enterprise model that I'd shown you before. And it's a similar type of a workflow over there, except this is going to then result in a causal impact graph of each of these features. Now, so one of the features, and this explanation agent, this PhD economist agent, is telling us a little bit about what the edges are like in the causal graph. And then based upon that, it's going to give us an interpretation of one of the features. And one of these features is, and again, it's not showing. Okay, so this is our enterprise business, and this feature is Germany new construction, change in the new construction amounts in Germany. It's like so that's the it's a sentiment score of that type of business that is connected to this 6 month prediction of our enterprise business. Okay, and so you're trying to what this is trying to answer here is, what is it? How is Germany new construction related to Cisco's enterprise demand? And so this agent over here explains to us what the potential connections are. There are about 6 of these connections, 6 possible reasonings for why that might be the case. Obviously, we have to go in and validate, and we've probably already done that because of why this feature is showing up in here, where it is representative of Europe as such. So it's not just some random feature that is showing up and doing this for us. So it's representative of a broader set of economic reality. And then summarizing the interpretation and trying to pick which is the most likely interpretation. So this way, if we don't have a PhD economist on our team, or someone who's working on the model, they have got this assist to help them interpret what is actually going on. So what's our future state? Model confidence. So I'll kind of use the same 3 sequences there. So EDA and model inspectors, I talked about those. Feature engineering for structured and unstructured data is a very significant area to build these new features. It's not easy. I think the reliability of these agents, I think, is going to get severely challenged when you start working with unstructured data to create coherent features from them. We've already seen that. You try to take PDF files with spec sheets for different products, and then you try to summarize what they're telling you, what the different features are into a table, and it's garbage in, garbage out, all right? So it's a very serious but a significant problem that I think we have to solve out there. But this is kind of really where we are when we try to build better models, when we want to start looking at product competitiveness and those kinds of things. This is super important for us. Also, I think being able to do things on the fly, brainstorming is a very powerful thing when we get together in teams, even individually, of course, but when we get together in teams and we say, hey, what about this? What about the rate of change of the number of customers that is transitioning from one product to the other? To be able to do this in real time is huge. It cannot be understated, because that then drives the development process much faster, the speed of development and modeling. So we think that's very big. Going to scaling, I think the high dimensional aspect of it, the ranking and evaluation, including uncertainties. So we think agents, the biggest opportunity for us is when we talk about a long tail of models. So maybe it's model number 300 to model number 1,000. Having an agent be able to build a model like that all the way end to end, that's reasonable. Without human touch, that fits into a new causal agent ops framework. I think that's what I think would be very, very helpful. Up-ratcheting all of this, all of these agents through reinforcement learning is a very big piece of it. Going into relevance and trust. So this is where having groups of models that are like a hierarchical set of models underneath a business entity, for example. We want to understand, what are they all telling you together? Maybe it's even your leaderboard of models. What is it all telling you together? Because maybe model number 1 through 10 have some signal, maybe some differences in signal in them. So being able to explore these models by business users, both inside the team, inside the planning team, inside supply chain, but even outside, I think that would be a very nice thing to have. And then as we discover things, we find that there are adjacent problems that would be highly impactful if we solve them, and then solving those adjacent problems faster. So all this within the context of the linear resource constraint that you have. So that's what I have for my presentation.
Thank you, Punit, for that insightful look into how you're approaching demand forecasting at Cisco. And now we have a question or two for you, and I'll turn the time over to Jerry to ask away.
A lot of questions, actually. One of the questions I had, Punit, and it just occurred to me as you were talking about, and like what Darko was talking about as well, is the change of how people work, leveraging agents. This is a very complex process. I think we all know that. We get it, right? This is incredibly complex, taking a lot of time. But fast forward 12 months. Like we're integrating agents into this forecasting process. We have the causal workflow. Maybe speak to how you envision the work of the data science team changing within this process as you introduce agents, and also how that might influence the consumption of the output of the team for the forecasting process. I know that's kind of new. Yeah. You didn't really talk about that, but I think it's, when you were speaking, I was thinking about, okay, this is going to change a lot. But yeah, I'd love to hear your thoughts around that.
I think there's a lot of more like agents that we can actually grab quickly, and they can dramatically change things. So I mentioned the EDA agent. That's very, very reasonable. You have the latest or the best way, the best known method, and then that is evolving. And so having a learning agent that is capturing this and then being able to generalize from one business or one product to another product, or maybe it's a sales regional forecast or something like that. There are differences enough, and I think that the fungibility of these agents can really help us be able to scale that and then build that and change the way that we actually are doing something. So it's like, it just dramatically, right now, there is a lot of human involvement. A lot of, it's like, I joke about this, but there's no one person in my team, that can make a call on something. It's because the problem is so complex. And so it takes multiple people, and then we are able to make the best decisions when we have multiple people involved in this thing. So with this type of a framework, we could probably do more and have each data scientist have and everybody have the confidence that, yep, people are leveraging the best, whether it's somebody who's 2 years into the role, or even if it's the most advanced user, right?
Yeah. Right, and then the consumption of it as well, because you talked about like PowerPoint and this type of thing. So agents can certainly influence the consumption of your output from the team. So I'm curious what you're thinking about that in terms of agents. Or access of the output thereof.
Access of the output, yeah. So 12 months from now, again, it's a huge pain point for us. It's today. The challenge is, I think when something is super important, there are enough nuances in there that it has to be done by an expert. That's kind of the nuances of all kinds, right? How can we get there? Today, it's a very manual process. Again, it's the team getting together and doing things. Can it be done faster in terms of the output? I think it's very feasible where we have a group of models that are saying something and they're being summarized largely by an agent. Okay, because again, it's very, very time consuming to do so.
Yeah.
So I see a lot of maybe it's the middle tier of models, or if it's a tail, of course, right? And I see us doing that on the tail. But if it's the middle tier of models, I can see that there is a huge significant assist that comes through where the core output is coming from an agent, and then depending upon, there's some oversight.
Great. That's all I had.
Okay.
Thank you, Punit. Appreciate it.
Right.
Our next speaker is leading one of the boldest digital transformations in Southeast Asia. This fireside chat is with Vince Iswara, the CEO and co-founder of Dana Indonesia, a fintech platform with over 200 million users and 40 million daily transactions. Vince will share how AI agents are powering a data citizen culture at Dana, where teams across the organization, not just data scientists, can access insights, experiment rapidly, and make smarter decisions at scale. Vince and Darko, over to you.
Fantastic. Well, Vince, thank you so much for joining us today. We are so excited to have you join us, this time virtually at the causaLens conference, but hopefully next time we can do this in person as well.
Yeah, no, glad to be here. Very excited to talk with you again.
Yeah, and just a very quick introduction on yourself. I'll let you introduce yourself, but from my perspective, what you're building is pretty exciting. You have brought 200 million users, and given them some pretty exciting product. But maybe you can tell the audience a bit more about your company.
Sure, thanks, Darko. Well, just quickly to reintroduce myself, my name is Vince. I'm the CEO of Dana. I'm the co-founder of the company itself. We started about well, 8 years ago. In fact, yesterday was our 7th year anniversary for the moment that we turned on our platform. So it's been quite a ride. We're serving now over 200 million users registered all over Indonesia. And we are doing about, 40 million daily transactions. And our job, our mission is pretty simple. We want to bridge the financial gap for the Indonesian and making financial services accessible to the mass market, and also to provide inclusion for them in a secure, fair, and transparent way. And myself, I've been 16 years in fintech entrepreneurship. Dana is Dana is more than like my third companies, but most of them has been tech-based, technology-based company startup, and I've been passionate about how technology can transform the society. And at Dana, we believe we're building the infrastructure for the future, and we wanted to make sure that we can bring what we call a safe and smart digital infrastructure technology. I myself also part of a World Economic Forum's technology pioneers, same as you, Darko, right? And I'm really proud to be part of it, and especially in helping on expanding and also scaling all of this technology like AI and innovations to really help people.
Yeah, that's. I mean, yeah, I'm really impressed what you guys are doing, and the scale at which you're operating, and your vision is truly inspiring, actually.
Thank you.
So it is, and I really think you guys are really changing the economy. Indonesia is actually a really exciting place to do this, right? It's one of the fastest economies, and whenever there is this kind of growth, you need to think differently, right? You cannot just rely on the legacy kind of systems. And I mean, that's kind of part of what I wanted to discuss with you today is, how can we think differently about AI? How can we use agents kind of that have just become possible to be able to scale in non-conventional ways? So I thought, there's no better person than yourself that has scaled something in a non-conventional way to kind of discuss also the future of how we're going to scale AI in a non-conventional way. So maybe we can start there. You can tell me a little bit about how you think about scaling data-driven decision-making at Dana, because you guys are growing at such a rate that you can't simply, do things the old way. If you're like a JP Morgan or something, you had 50, 100 years to kind of like build out things. But when you're growing at the rate you guys are growing, one must think a bit different about scaling data decision making there. So maybe just give us some thoughts on that.
Sure. No, definitely, Darko. Is I think as everyone has experienced, right, with this explosion of all these innovations and technologies, especially we talk about Gen AI, the need for us to process more and more data in a scalable, in faster and also safe, is just becoming more critical. We realized very early on that not just technology but data itself will be pretty much what drives our innovation and our growth. So we want to make sure that we are a very data-centric company, and just purely relying on a very traditional data science, it's not good enough. It's limited. So we want to make sure that we are able to use our data more effectively. And this AI innovation has also given us kind of a path on how to do that better, because like you said, right, we scaled very fast. We scaled pretty much in the last 4 or 5 years, and then our data growth and our talents, our teams, resources growth, it's very hard to keep up if we just keep using the traditional way. And so we need to rely on the modern or a much more advanced way on how to process and how to enable all of these people to get more and more access to this data. In fact, recently we've also involved like global companies. We talk with companies like Google, with companies like Microsoft, and how to actually help us as well, and how to process out such a massive amount of data. Because right now, with the current ability for us to have direct connectivity with the users, to have information flowing through transactions, through payments, through their biometric, active or passive biometric informations, all of those data, it's such a powerful and strong elements. But if we can't process them and we can't enable our teams and our people to have access to those data, then it's pretty much has just become useless, right? So that's why it's so exciting to work with you, because now we want what we call a data citizen mentality to be implemented in our company. So every single person, not just the engineers, even the business people, even the operational people, will have an access to this data set. Whereas before, pretty much everyone who wants to touch that data, who wants to understand that data, they have to learn how, for example, have to do SQL. They have to learn how to do, data science skill set. But now with all the innovations that's happening in the market, it's becoming more and more accessible. So it's a very exciting time.
That's right. Yeah, I mean, we see this with our other customers as well. You have usually, a small, data science team. They're great usually, but they are just a small team. And then you have, thousands of people around the business that want to make better decisions with data, but they all kind of go to the data science team, and they're kind of getting in a queue, and this queue keeps growing.
Yes, the backlog is becoming 1 year long backlog, right?
And then by that time, the data science team gets to it, it's no longer maybe even relevant, project. And so I think in your world, you guys are generating a lot of real-time data as well,
exactly.
Right? And that data cannot wait. Like the insight, you may need it in like few minutes, few hours, few days, which is simply kind of not possible for like the traditional approach to manage. So yeah, we're really excited to be partnering on enabling everybody to have their own AI agents that they can use as data scientists. So that's pretty exciting. So could you maybe take us through where do you see kind of the key use cases for this new agentic technology in your business? Like where do you think, what are the first 5 big use cases that you think it will unlock?
Sure. I think that's the thing, right? It's having the data and ability to process the data itself. That's just the beginning. I mean, the important, it's what can we do with that, right? So some of the exciting things that we are, deploying, and we're already kind of in the middle of it. We started like a year ago. Now we're kind of in the middle of it. It's one when we talk about fraud preventions, right? And I think that's definitely some of the areas I'm sure every financial institutions would love to have implemented in their day-to-day as business operational. And then second thing is when we talk about customer support, it is like, traditionally, if we have a customer support agent, so when they want to solve a problem for the customers, then we have to either train them, educate them, or we give them fact sheets. And no matter how fast we can do that, it's going to take time for us, right? I mean, it's probably going to be monthly or quarterly, where instead, if we have an AI agent to be able to interact directly with the customers, every features, every know-how, knowledge base, every issues that we handled or we solve will immediately become accessible to every one of them. So that's the kind of things that the data, ability for us to process the data and understand will enable us. And, other things, for example, like content creation as well. We do have a strong marketing, especially in regards to providing educations for financial services. We need to have not only a strong way to broaden their awareness, but also creative content to also help them to process information better. So we're also using AI as well on creating this content generations. Fourth, we also understand about public sentiments, right? We want to know how are the people comments about us, when people talk about our services, when they talk whether or not it's positive or negative or something that we can improve. Those are, four of the sets that we already have it in our pipelines. And the fifth one, we're just also excited about, is actually on how we can onboard users and merchants better. So for example, if they want to integrate with our technology and services, or they want to have a faster engagement in managing in the contract or agreements through all of this agentic AI and also ability to process the data and faster and figure out any issues faster. That's definitely top 5 in our pipeline right now.
Yeah, that's a really interesting one around the customer experience. I feel the legacy brands in financial services almost don't really care about the customer. Like I don't think I've actually felt heard or listened to. You just get an app built in the 90s and kind of that's all you've got, right? Even the branches are closing, so you have nowhere to really complain. So I think what you guys are doing there with that real-time information from the customer, it's pretty exciting. Have you actually had the chance to connect that to kind of what is the impact on customer retention or customer?
Yeah, oh, definitely.
Yeah, I'm sure it's, but maybe the audience may like to kind of hear, and maybe inspires the old banks to also take.
No, sure. I mean, well, it's okay. Let's talk with the first use case that we had, right, with the customer, what we call support and engagement. So right now, about 90% of all the contact ratio that we have in our platform are actually managed by the agentic AI already. We're doing about, let me think, because we're doing about 40 million transactions a day. So if I'm not mistaken, we have about 20,000 a day of a contact ratio. And whether or not that's included queries, complaints sometimes, or just informations, that's about 24,000. That's a month. That's pretty close to already like 750,000 contact ratios, right? So if you have to manage a traditional way agents, like a normal human agent models, then you require thousands of them. So instead, since 90% now is handled by our agentic AI like model, not only now we're able to solve or we're able to provide info faster, our CSAT actually increased. Yeah, CSAT is customer satisfaction index, right? So, and why is that? This is exactly what we've experienced, because with the agentic AI, there's very little wait time. There's very little what we call transfer of between agents to provide a much better information or much superior know-how, right? Because sometimes one agent doesn't have all the full knowledge know-how, right? Through this agentic AI, people can get information from very beginning to the end, successful complete whether or not there's transaction issues, whether or not informations and queries within one session. And that's just like, oh, now my problem is solved. So, and it's fast. I don't have to wait. I don't have to, right? When you do call customer agent, sometimes you have to wait a long time to get your served. Now you no longer have to do that. So that's just one area that we see in a massive improvement. And because now we also have more and more data of the people that's happy. So now we can, or the people who are taking longer than necessary, then we can also go back to improve our product. So which type of the product prioritization that we can do? Because now we have such a faster data loop back into our system. I think that's just one exciting thing. And second things that we're very excited is the integrations. I'm not sure if you, but if you talk to all the financial institutions all over the world, not just us, but including the banks, the digital banks, traditional banks, or fintech, integrations with third-party merchants has been one of the biggest pain points. Now we are able to have end-to-end interactions for that integration fully managed by the agentic AI.
Wow, that's incredible. That's really next level. I mean, I imagine, what one day, Vince, we'll see your company turn into a super app. Is my prediction. You guys are gonna do far more than what you do today. But that seems like a first little step.
Well, we still want to focus on financial services because that's our passion. But hey, we know if people want more of the service and we're able to provide them, why not?
Nice. Very good. And so when you look ahead and you think about agentic systems for data analysis and data science, where do you see, say, over the next 3 years, the biggest unlock that this technology can create? What's your expectation in terms of like how data looks like 3 years from now once AI agent for data science can be kind of fully implemented? Like, what's your vision of how the business looks like then?
Sure. I think one thing that we want to make it clear, we believe in upskilling our talents. We believe that, and that's why for us, having this agentic AI does not mean we want to replace our workforce or we want to replace functionalities. Instead, we believe that AI, even agentic or the data AI itself, we want to upskill and we want to augment their productivity. So because of that, we truly believe once we implemented all of this into our platform, we can make, like a faster decision making. I think that's very important, right? Because at the end of the day, all of this data, it's really to help us to make a better decision making process so that we can unlock new revenue opportunities. We can unlock new product roadmap, and we also want to unlock new areas where we can improve so much faster. We also, of course, and this is pretty much already been done by everyone else as well, is that we want to unlock significant cost savings by automating, like, tasks.
The boring part.
Yeah, the boring part, right? Automating. Yeah, exactly. It's like the part that pretty much you just do the same thing every day. It requires very little brain cells, right? So we do want the people to be more creative, to be more insightful, to be able to really understand and also explore, experiment. I think that's really what people are. So, and the AI itself is just help to automate the repetitive stuff. And finally, of course, we want to, as we've been saying from the very beginning, to improve the customer experience. I think that's always been the key for us.
That makes sense. Many people, when they hear agents, immediately their mind goes to, oh, we don't know, we're not going to need people, or we're going to replace people. But actually,
no, I don't believe that, right? It's people still people.
Right? Exactly. Yeah, and I think, I think someone I heard the other day talking about, hey, if we just passed 2 laws, ban tractors and ban fertilizers, we're going to have, tens of thousands of jobs, but, no one would want to do those jobs. And I think it's very similar, with this AI revolution, agentic revolution, is that, we want to make the jobs better for the humans.
Yep.
Be able to do more. We want them to have more fulfilling jobs and things like that. The other fascinating thing is what you said earlier is it's not just about getting humans, make their job easier, but it's also about unlocking, tremendous business value that you simply cannot unlock with human-driven processes, right? If you have to wait a few weeks, maybe that opportunity is gone. Your customer may already be annoyed for you if they have to wait for 3 weeks until they get something. You would rather get them, in 2 hours from when they experience.
Exactly.
Those things are kind of like perhaps a little bit underappreciated today, but obviously you and your company understand that super well, which is why we're so excited to be partnering with you guys.
Yeah, I mean, one thing that I can highlight as well is like, it's literally just a few days ago, one of the key elements in providing higher customer experience is about experimenting, right? I think that's the thing, because it's almost close to impossible to get things right in the first time for everything related to human, customer journey. So now with this agentic AI, with us, with our ability to make everyone into a data citizen, so because they can process data faster and faster, and now we can experiment more. So instead of having 1 or 2 or only 3 scenarios, you probably can, by 1 week, you can have 20, 100 scenarios that you already experiment on. So by the time they're done, they're already creating something that is so, we call it like reinforced learning, right? So basically, you're already done so many things to make sure that the product that you're trying to deliver, it has fully been experimented on.
That's right. And Vince, maybe I would love your advice for others that are not as fortunate as you and your team. You've embraced on this journey very early on. You really adopted it as soon as it has become possible to adopt. So, really, really congratulate to you and your team. Obviously, your team is excellent. Incredible work. But for the people, for other companies which haven't been as brave as you guys and as early adopters and as fast moving, and are still relying on gut feel to make decisions, and maybe they're just wait and see posture, what would be your advice for them? What drove you guys? How did you create a culture where one, you can attract people that can do these things, but two, to incentivize them to adopt the latest technology? Would love your advice. I think a lot of people here in the audience and more broadly would love to learn how you created this culture of being data driven as opposed to gut feel.
Okay, so I think that's one thing, right? It's it doesn't. I'm not diminishing gut feel, because sometimes to times it's very much relevant, right? I think both of us will not be where we are right now if we don't use that gut feeling. But that's the thing about gut feeling. I mean, gut feeling, it's you probably only able to envision a direction. Like you probably is like, hey, that's the direction I should go. How do I get to that direction? That requires data.
Yeah, that's a really good way to visualize, actually. Yeah.
Yeah, right. That requires data, and the more data that you have, the faster you get to that directions. I think that's the key here. It's not. It's you cannot eliminate both, but when you can have more data, you can process more data. When you can experiment on that data, then it's just the more straight line that you can get there. And one thing that in our companies that we also believe in, and we put that as one of our culture itself, is that don't be afraid to make mistake, right? But if you now have ability to process that data faster, you have the ability to generate, to process feedback loop, and also to execute and make decision on that data faster, then the margin of error, the time of making that error becomes smaller. And that's when it's becomes so much powerful. You cannot avoid mistake. Let me tell you, in any innovation, in any new ventures, in any new product, you cannot make mistake. But with all of this ability now, it's just you make less, you make it faster, and you can improve faster, and you just get there faster. So there's really no downside to this.
I love that. It's why do you want to go in a zigzag and very slowly when you can get there in a straight line and much faster, right? Exactly. I think that really summarizes this conversation very nicely. Vince, I'm so grateful for your time today. Really, really excited what you guys are doing. I wish you continued success. And yeah, really excited to be partnering and doing things together. So yeah, thank you so much. Hopefully next year we'll also do this in person. We were thinking also maybe doing something in Asia next year as well. So that could be a good opportunity.
That would be wonderful. I'm really looking forward to see you again, Darko.
Thank you so much.
Thank you. Bye.
Thank you to Vince and Darko. That was an exciting look into how AI agents can empower entire organizations and not just experts. Now we'll take a brief break, so enjoy a nice cup of coffee, make connections, and we'll meet back here at 12:15.
wish I could go back when we were young. Yesterday, another moment we let slip away, slip away. I'm here to stay. Call me a dreamer, but I'm wide awake, wide awake. The only way to know where we're headed When I was 6 years old, I broke my leg. And I was running from my brother and his friends, and tasted the sweet perfume of the mountain grass I rolled down. I was younger then. Take me back to when I found my heart, broke it here, made friends and lost them through the years. And I've not seen the boring fields in so long. I know I've grown, but I can't wait to go home. I'm on my way, driving at 90 down those country lanes, singing to Tiny Dancer, and I miss the way you make me feel. It's real when we walk.
Hello, everyone. Welcome back from break. I hope you enjoyed your coffee and making connections. Next up, from McCann World Group, we have Annie Howe, SVP Global Head of Data and AI, and Hayden Russell, Group Research Director. They'll share how Causal AI agents are helping measure long-term creative impact through the Brand Endurance Index.
Hello everyone, my name's Ollie and I'm part of the go-to-market team here at causaLens. I'm thrilled to be joined by Annie from McCann World Group today to discuss how we are partnering to bring data science agents to life for McCann. Annie, thank you so much for joining us today. We're excited to have you and the McCann team with us at the causaLens conference.
No, thank you for having me. Very excited.
To start, it would be great if you could provide a brief overview of McCann and also tell us a bit about your role there.
Yeah, absolutely. So I'm Annie Howe. I'm the Global Head of Data and AI for McCann World Group. My role focuses on leveraging data and AI to create data-driven products and AI-driven products and services for all of our clients and also for our internal teams. McCann in general, or McCann World Group, is part of a larger IPG network, and we're focused on being we are a creative agency focused on building beautiful creative work, and some of our biggest clients are L'Oreal, who we've worked with for 50 years, and MasterCard, and so forth. And while we're looking at always building amazing, beautiful creative, what we really want to do is really have effective work and make sure that our work is driving business sales and business outcomes. So creative effectiveness is really at the heart of what we do, which is why we've partnered with causaLens.
Amazing. So as part of our engagement, we're working on the brand endurance work, which Hayden's going to take us through a bit later on. So maybe just to start, it would be great to get your perspective on how you see data science agents transforming marketing agencies and also specifically at McCann.
Yeah, so as I said before, creative effectiveness is at the heart of what we do at McCann, but it's also at the heart of the industry. So there's no point putting out creative work that really isn't going to do anything or move anyone. So while this is super important at the core of sort of our ethos and our strategic approach of truth to impact, it's notoriously difficult to measure and notoriously difficult to analyze. So what we're seeing with AI data scientists is that, and the Brand Endurance Index project that we're working on, is that we're hoping to close the loop between measurement and strategic output. We're trying to sort of use our proprietary approach to sort of measuring brand along with sort of AI data scientists to sort of make that analysis and make that sort of work accessible not only to sort of our technical team, but to everyone in McCann World Group. And so we're hoping for sort of more efficient work, but also really hoping for the ability to empower our less technical teams to sort of leverage this amazing sort of insight and drive the work that they're doing. So I think in the past, we'd really sort of have a technical blocker in having someone have it to translate a model. And I've tried showing causal graphs to our teams and they never go down well. So having AI data scientists and sort of that work as part of our workflow, we can empower our less technical teams to really leverage those insights in their day-to-day work. And that's really something that helps us close that loop.
Amazing. So you touched on a couple of themes there around kind of efficiency and enabling less technical users perhaps to interact with the data-driven work. So as AI data scientists become more embedded in workflows, what do you see the impact being on efficiency, decision-making, and ultimately business outcomes?
Yeah, so we've already started piloting the work on the brand endurance with you, and we're seeing it have massive impacts on both ends of our scale. So at the sort of beginning and development phase, AI data scientists are really helping us produce repeatable, reproducible work very, very quickly. So typically, a brand endurance analysis or any kind of creative effective analysis would take weeks to months and take like a really technical data scientist to do. With our AI data scientists in the causaLens platform, we can reduce that time to say days to a couple of weeks, meaning that we can offer this invaluable service to all of our clients. It also means it's less resource constrained, so you don't need a technical programmer anymore. You can have someone that's less proficient in coding, sort of running these workflows because it is so reproducible and so quick and easy to use. That's more from sort of the input side. On the output side, what we're seeing, again, as I said, massive impact on decision making because we're democratizing those insights. Yeah.
Amazing. Yeah. So you mentioned that before you were using AI data scientists, it was taking kind of weeks, or possibly even months to do these types of analyses.
Yeah.
So right now, a lot of companies do still rely on fully human driven decision making. Do you see AI data scientists as a necessity going forward, or kind of like a nice to have?
It's absolutely a necessity for us. So I think the state of the world and the state of our industry is that we're seeing more and more demand of proof and more demand of evidence. So not only in the effectiveness of the work that we do, but also in the evidence that we provide in our strategic sort of thought process and our creative decisions. And so what AI data scientists are allowing us to do is sort of allow us to use that combined human sort of input in the way that we sort of build our models, but then also make sure that those insights get democratized to everyone on our team. So we're again focusing on sort of speeding up the front end of that development process, and then also making sure that those insights get made available to everyone across our strategic, business, and creative teams.
Great. So yeah, it's amazing to hear how it's working on both the creation side and the consumption side, I guess, as we think about it.
Yeah.
And so, having recently started using AI data scientists, what early signs of impact are you seeing specifically at McCann?
What we're seeing again on the sort of creation side is like a huge sort of reduction in time. So again, time and also sort of the technical expertise, because this really impacts sort of our resourcing. So rather than having to find that one sort of data scientist who not only knows how to code really, really well, but also understands causality, we can now sort of empower our more junior teams or just teams around the world to leverage these workflows and leverage these causal notebooks for both causal discovery and modeling. So that's really helping on that side. So that impacts the way that we sort of hire. It impacts the way that we sort of leverage this analysis for our clients. And again, on the output side, because we're able to do this so quickly, we're able to offer this to all of our clients, as opposed to just the ones who can afford this amount of depth of analysis. And then also making sure that, again, these insights can be used by our strategy teams, because again, I am a data scientist and I love it, but the way that I think is quite different from a strategist. So making this a tool that is in their hands means that they can query the model and ask questions that I never would. So it's really beautiful on both ends of the spectrum.
Amazing. Well, thank you very much for taking the time, Annie, and looking forward to Hayden and Tig to break down the work in more detail.
Yeah, thank you. Have a wonderful conference.
Thank you. So we are going to pick up now on some of the themes that Annie and Ollie just talked about within that video. So what we'll specifically be talking about really is our new approach then to measuring creative effectiveness. So where we're then moving beyond actually really focusing on those short-term outcomes and actually really looking to that long-term impact that our creativity generates. And we'll be specifically then looking at the role of data agents in both informing that creativity, but also then providing the framework with which we then use to measure it. So as Annie mentioned, we are a creative agency, and of course, as an industry, we are obsessed with this idea of creative effectiveness because we need to make sure that our work works. That is something at McCann that we take very seriously, and we are proud of the fact that both the industry and our clients recognize that about us. But it's a challenge. We know that it's particularly hard at the moment. We're working in increasingly fragmented markets. Brand trust is at an all-time low. And so actually, therefore, what that really requires is having a laser focus on the outcomes that we want to achieve, having both the insights then and the creative capability to generate the work, but also then a really kind of robust measurement framework as well to deliver it. And so that's really then the challenge that we have embraced. And we've done that then in two different ways. So first of all, we have developed a measurement framework, which again is really designed to help measure that long-term brand impact that our creativity is generating. And so that's what I'm going to talk about, what we're calling the Brand Endurance Index. But at the heart of that as well is then Causal AI. Again, that's what's helping really inform those outcomes that we want to achieve. It's making sure that our teams across the business have access to those insights, and that, therefore, is really what enables our creativity as an agency. And that's what Tig is then going to talk about. So I already touched on this a little, but when we talk about creative effectiveness, what we're not talking about exclusively is just this idea of what is that short-term sales uplift that we get from a single campaign. Instead, we really are having a look at that long-term brand impact that we're creating, which is that kind of amalgamation of all of the work and all of the creativity that we're putting out into the world. And so the way then that we really talk about this, McCann, is through this idea of building enduring brands. So it's where our brands have the power to win today, but it's also then where they have this ability to navigate changes in consumers, categories, market contexts, everything to be able to remain relevant and still have that power then to keep on winning into tomorrow. And we know that that matters when we actually build brands that are specifically engineered to focus on those long-term gains. We know that it builds commercial returns. So whether that is those enduring brands having a 2 times higher market cap, generating twice the consumer demand, or being able to command a 40% price premium, again, we really know that there are those commercial returns that are enabled by focusing on that longer-term impact of our creativity. But it actually also expands beyond that as well. And we've also had a look at it through the lens of an EVP, so employee value proposition, where we've seen that those enduring brands even have a 4 times more highly engaged workforce. So again, really justifying then that approach that we have in focusing on the long term. And when we do that, we really focus on 3 different dimensions, which is our framework both for then measuring creative effectiveness, but also then the different building blocks that we can use to help inform the way that we actually achieve that creativity. And that is then through this idea of commanding the category, connecting with communities, and charting culture. So when we talk about commanding the category, it's where a brand really understands consumer needs, it ties itself to them, uses creativity then in service of actually building brand distinctiveness and noticeability, and creates this sense of forward momentum for the brand within the category. When we talk about connecting with communities, it's where a brand really actually understands the consumers that it's seeking to talk to, uses that to build up a sense of emotional connection and a unity amongst its user base, and drives lasting anticipation. And for charting culture, I think for brands to truly kind of drive culture is actually quite a difficult challenge and often unrealistic. I think actually what brands are better able to do is really to ride the waves of culture. And so that could be, for example, a brand actually pushing more into something really kind of altruistic and purpose-driven, but it doesn't need to be. It can also just be where a brand is tying itself to a lot more fun, kind of irreverent popular culture moments or trends, and uses all of that, again, in the service of actually really starting to shape the category trends. And so we use those 3 different building blocks within a quantitative survey powered by Causal AI to really help do 2 things. First of all, as I mentioned, actually really start to measure the impact of the creativity. So it's our tool so that we can measure that long-term creative effectiveness. But we can also then use it to help start to fuel our ideas as well. So we do that again through Causal AI, but also then through actually having really kind of open exploratory questions within our survey, which begin to ask consumers who they are, what's important to them, expanding to category questions like the role the category plays, the benefit it provides to their lives, the trends that are shaping it. And all of that then is really what enables us to help both fuel creativity, but also then measure it as well.
Perfect. Thank you very much, Hayden. So in terms of tackling these challenges then, as Hayden mentioned, we had this really rich survey data set that captured hundreds of dimensions of how customers thought about brands, reacted to brands, and the way they valued them. So from this, we identified kind of 2 key challenges. So as Annie mentioned, we wanted evidence behind these kind of conclusions, behind how we'd communicate with the brands we worked with. So one of those parts was, how do we actually build a model in the first place? So this is the kind of Causal AI versus traditional ML part, where due to the way customers think about brands and communicate in a survey, there's a lot of highly correlated variables that all kind of confound each other. So what we wanted to be able to do was identify, well, actually, what are the key drivers? How do we disentangle all of these effects and identify the actual impacts? And then the main part is then, okay, let's say we've solved that problem. Well, actually, we need to be able to do it at scale. There's no point in being able to do it once, because we need to be able to do it repeatably for every brand in every market multiple times a year. So that was the kind of key challenge here. So the way we really tackle this is through automation and using agents to run this pipeline and to clean the data and allow the McCann team to do this as often as they want, effectively, across geographies and everything. So as an example here, we're showing one of the data preparation agents that we have here. So the survey data was pretty messy, pretty varied. So depending on the market, there's a lot of very flexible questions with a lot of huge amount of dimensions being captured, which made it challenging. And this varied, from month to month. It varied from market to market. So we didn't have an exact data definition that was always the same. So we needed something a bit more flexible that would allow us to be able to do this analysis in a quick, repeatable way without having to hard code everything. So here we have an example of our data preparation agent that could take in this survey data and transform it, clean it, do the validation, the testing, etc., and converse with the data scientist to raise any issues or flagging things, etc., that might have come up that might have varied from previous times. So what this does, it allows you to really quickly go from the kind of raw, direct survey data to prepared data for the pipeline. And this massively speeds up the time. As we saw in Darko's talk, the huge amount of the time was this original data prep. The next part then was actually embedding this and grounding this in our causal pipeline as well. So beyond just the data preparation, we also wanted to do the modeling, do the analysis, etc. So as I mentioned, we don't have to have it be a very technical user. So just giving a clean data set isn't enough. So we grounded that in causality in our modeling pipeline, etc. And the first time we did this was quite manual. So as Hayden was mentioning, and Annie was mentioning, it's a difficult process. It is challenging. So we did it in a manual way the first time, and we used all the domain expertise that Hayden has, and we worked with that in an iterative way. But as we were doing this, we were bearing in mind that this isn't a one-off research project. We're going to be doing this again and again. So we took those learnings, we took that pipeline, and embedded an agent that had the knowledge and the context of that, which was then able to adaptively do this over and over again in the changing circumstances and the changing data. So that's what we're showing here. So that really allowed us to do this analysis at scale. So now we could do it for as many markets as we want, as often as we want, for every client, not just the most expensive ones. The next thing then is that for this to be valuable, it actually be in the hands of the people who make the decisions. There's no point in doing all this work if people can't actually use those insights. And even if they want to use those insights, you want to be able to use them in the best way. So a lot of the time what that might mean is, okay, we might have high-level insights, for, say, the entirety of the US, but a particular strategist might be working with one brand, and they care about maybe a specific demographic that they've seen they're lagging behind in sales. So in this case, you might typically go to the data science team and ask, oh, I need this specific analysis and another breakdown. And what this does is, when you have hundreds of strategists like McCann does, it just inundates the data science team with all these requests. So effectively, you're bogged down. We've seen it from the previous talks around this kind of backlog of requests and things like that. So what we wanted to do is be able to kind of centralize these insights so that the strategists could come and kind of get these types of questions answered that they wanted when they wanted them, without having to wait and kind of put things into a backlog. And we wanted to be able to, scale this to effectively any number of things and scale this to non-technical users. So again, what we did then was we took another data science agent, really in the consumption layer. So allowing this, again, grounded in the model. So the data scientists use our agents to build the model, build the data, and then we take a further consumption agent and ground that and allow the strategist now to converse with this and talk with this in natural language and ask questions in a way that maybe a data scientist wouldn't, and maybe the model doesn't know, but by grounding it in that context, it's able to infer what the intent is and actually kind of do these more ad hoc analysis, but do these in a way that's repeatable and reproducible because it's all grounded in the model the data scientist has built. So what this looks like here, for example, we can see an example of a strategist can come in, they can ask a specific question about a specific brand. So maybe they care that this specific brand is lagging behind in the US market. Why is that? So we might see, for example, that actually customers are observing that relative to its peers, it's falling behind in community. Okay, that's one sort of insight, and that might be an easy high-level thing, but now you want to dig into that. Okay, it's not just enough to tell my customer that they're lagging behind in community. Why is that? What are the actual drivers of that? So we might see, well, actually, customers perceive them as like less novel in their creative marketing compared to their peers and things like that. So that might be one sort of insight. And that's the why and the attribution. But we also want to be able to actually make decisions based on that. So the next layer then, as we're seeing here, is around running scenarios as well. So we want to be able to say, okay, well, actually, traditionally, we know that the creative work we've done with them is focused on something like value. What if we were to say change the perception from value to something more like quality or reliability and things like that? How would that impact? So through this model and through this understanding, where with the survey we've effectively built a model of the customer, we allow the strategist to easily run these scenarios in the language that they're familiar with, and then go back and talk to their customer quickly without having to kind of go through this whole data science process. So that was hopefully what we've enabled with the team, and we've been in the early kind of testing of that and exposure of that, and hopefully we're seeing value.
Yeah, absolutely. So, I mean, we are able to do this so much more quickly now for our clients and across a much broader range of clients. Even very recently, we had a challenge from a client that we were able then to actually diagnose what the issues were, what the growth opportunities were, and basically have that brief, do all of this process, and actually then be in the US from the UK a week later with a full kind of presentation that actually outlined what the challenge was and the way that they could solve it. So it really is actually then enabling that speedy process and again, democratizing those access to the insights. But I guess there's really kind of two different ways then that we have been and will continue to anticipate to use this into the future. And again, we've really built them around the two concepts of actually how do we measure and demonstrate that impact versus actually how do we fuel the creativity that generates that impact. So we've used it in multiple different ways. So for example, understanding which of our different marketing activities are going to have the biggest impact on sales. Really starting to get a deep understanding of the consumer and what their needs and motivations are that we can start to address in order to achieve those outcomes that we're striving for. What the different brand associations are and attributes that could actually then start to deliver against that. And who are our high impact audiences that we can actually reach in order then to be able to have those desired outcomes and impacts that we're striving for. And we use it then to fuel our creativity as well. So we can really start to actually funnel down in terms of understanding what's the broad conceptual territory we should be going down to, all the way down to the very specific messaging. So for example, we can understand, okay, for my brand, we need to identify what is the right strategy or strategic territory that we should be going after, which is the most fertile territory that we can go for. What's then the right concept within that of all the different ways that we can actually bring that to life? And then actually, what's that specific message, that one really pointy way that we can talk to our consumers about this overall conceptual territory? And again, run limitless scenarios about what that can do amongst our different audiences, amongst our different regions as well. And really then, as I said, doing that amongst our different audiences, so being able to identify what that impact will be and those different sources of growth. So that really is how we're using it now, by really being able to both identify both the sources of creativity, but then also being able to measure the impact that we have, and doing that in a really much quicker way that is providing that broad democratized access to these insights. That's it.
Thank you, Hayden. Fascinating to learn more about creativity with causality. Next, please welcome Dr. Juan Carlos Araki, Principal Scientist, Process Science and Modeling at Johnson & Johnson Innovative Medicine. He'll explore how causal inference is transforming pharmaceutical manufacturing. Welcome to the stage, Juan.
Thank you so much. Thank you so much. I'd like you to think for a second on this hypothetical situation. What if we were sick today? Most likely, we won't be here in attending this wonderful conference, right? But much worse, what if we had some sort of chronic illness? Well, we will not be able to enjoy the things we love doing in life, right? At Johnson & Johnson, we care deeply about healthcare. We're a mission-driven company. The patients are the top priority for us and their health. And that's why we're very passionate every day about innovating across the full spectrum of healthcare, from pharma to medical devices. In the pharma sector, we have a specific organization called Manufacturing Sciences and Technology that precisely does that job, innovating and providing technical support for our network of manufacturing sites across the globe. Within this organization sits our group called Process Science and Modeling. And I like to think about us as some sort of data scientists on steroids. We're a group of chemical engineers, physicists, chemists, who know deeply about our manufacturing processes. And know quite a bit of mathematical and computational modeling. So we are about one single mission. How do we help these manufacturing sites make the best science-driven business decisions? And those business decisions might be across the full spectrum, from releasing a product real time to controlling actively the process, the manufacturing process, to improving cycle times and yields, to sustain the quality of our products across the full life cycle. So that's why we are embracing Causal AI. We cannot let the quality of our products to depend on chance. We need to do much better than that. The risk to our patients is very high. So we are very aware that we cannot make good business decisions based on traditional machine learning or data-driven modeling. We want to move into that paradigm shift of doing more scientific-based decisions. Sorry. And that's why we are partnering with our friends at causaLens. We have developed a comprehensive plan about using Causal AI and data science agents to enhance the way we make the business decision in commercial pharma manufacturing. And the causal drivers are many, but we're joining forces basically to empower our leadership to have tools to make these decisions in an intelligent way. And so we're combining our data with our expert knowledge about these processes, with causal discovery algorithms, with causal models to build and deploy the tools where we can do things like root cause analysis, tactical or strategic decision making. I'm going to take you through a few examples, high level, of how we have been doing that so far. So here is the first one. Let's say we have a typical situation of root cause analysis. One of our products went out of a specification because it didn't meet the required release specification limits. And so we want to know what happened. So we were able to build a very detailed causal graph for this process, starting from over 100 of parameters to use human-guided causal discovery to develop the right model for this process. We then apply counterfactual predictions to understand where the process was failing. We realized that it was actually towards the end of the steps of the manufacturing process. And we were able to understand that this issue arises because of a recent process change we have done at the end of the manufacturing process. Basically, the way we were taking our samples for quality were not representative enough. So the actual quality assay was correct, but the way we were taking that sample was not. And so that led to this issue. And we were able to build and deploy a root cause analysis tool for the business after that. Now, moving into the more tactical decision-making process, we had this very interesting situation where we were asked to assess some type of timing intervention that was required due to a logistic change in one of our manufacturing facilities. And then the question was, what if this affects the critical quality attributes of our products? And so we went on and built a specific structural causal model for these situations that included, obviously, our parameters, timing parameters, and our critical quality attributes. We then applied intervention sampling across the full spectrum of short to medium and long times, and were able to assess the risk of each one of these situations. And so we were able to convey this to the business, and it turned out that the risk that was assessed was within the tolerance levels that were acceptable, so the manufacturing side was able to implement this change successfully. Then moving into the more strategic decision-making, we had this very typical situation too, where, hey, there are multiple options to improve the yield of our processes. We want to identify the actual effect of these potential improvements and decide whether or not we can make the required investments. So we were able, again, to build a structural causal model with the key parameters that were about this intervention on the process and the final yield outcome. We then applied all the beautiful math of causality. We were able to use the calculus, mutilate the graph, and determine our effects in the yield. And in this case was a positive effect of increasing the yield. So that led to the business to actually be able to build a business case for this project, and now it's in the process of evaluating further down the road for the implementation. So across these experiences, right, we have realized that, again, we have learned about many of these successes. We want to be better about internalizing this capability, about communicating that to leadership, and making sure that we can scale that up through the rest of the organization. So looking forward into the future, we're very sure that, again, enhancing what we have done so far with the data science agents to automate these processes will lead us to a better place, and we're very much looking forward into that situation where we're having causal AI as part of the standard way we take business critical decision making. And with that, thank you for your attention, and yeah, happy to take any questions.
Thank you, Dr. Raki, for that powerful look at innovation that saves lives. Next, we have a couple questions for you, and I'll bring Jerry to the stage to ask.
I would say if anybody else has any questions, thanks for going through that one. You did that quite fast for such a complex process. You made it simple. First question I have for you. So you mentioned that your team is a team of data scientists on steroids. Now, what if you had an additional 100 or maybe even 1,000 data scientists on steroids, right? And let's call them AI agents at this point. What do you think you could achieve that you may not be able to achieve today?
Well, definitely these different opportunities that we shown before, right, where in a particular small branch of our product portfolio, we have a huge product portfolio going across what we call synthetics, sort of small molecules, large molecules, the biologicals, biopharmaceutical, and then cell and gene therapy. So a huge opportunity to scale up to many of these situations. Interestingly enough, when I was having this conversation with one of our data scientists from causaLens, many of our manufacturing processes at the commercial level are very standardized. We almost do the same for each and every product, except for a few variations. Yeah. So having that idea of automating the way we run through the data and scale up to different products is going to be the future for us.
Yeah, no, that's exciting. A lot of money there too, I think, from a cost savings perspective.
Products that are billions of dollars per year.
Yeah, no, that's really exciting.
Yeah.
Really cool. Second question I had for you is really with regard to, as you think about where you start. You know, some folks are, you know, watching this, you know, here in the room or online, and, you know, they have models that they've created. They could be causal models, maybe not, by the way, causal models, but they're wondering, okay, agents. They sounds cool, right? And you know, our partnership with you is just kind of getting started, if you will, on the agentic side. What is your sense on where would be maybe maybe some recommendations on where to start? I guess if you know, starting from where we are today, which is we have wonderful kind of output, wonderful model, but now we have to agentify. Like now we have to think about workflows. Where would you start?
I mean, definitely, I love that video that Darko showed at the beginning, where you were doing this root cause analysis in this sort of chat way with an agent, right? I would love our, investigators every time they're running one of these root cause analysis investigations. It takes them about a month to go through everything to, solve just one case. So the way we scale that up is by hiring a lot of people, right?
Yeah.
If we have these kind of tools, right, can we do it in a day or less, right? And then automate the way we do it, but also to scale up, right? In terms of how do we solve these faster, and then develop corrective and preventive actions that will get us to a better place, right? Because if it takes us a month to understand what caused a problem, right, that's time that we're losing, especially time for the patients and obviously profit for the company.
Yeah, no, it's really good.
Yeah.
I think we have a few minutes, right? Any questions maybe inside the room? Anybody want to ask any questions? Yes.
So while the agentic AI offers a lot of traditional, groundwork that we do, but a lot of time, some of that involves a lot of critical thinking in terms of the right questions we can ask, and the right way to automate it, because the AI may not be able to give you the best solution always because it's limited with the data it's trained on. Yeah. And so how do you compensate for that?
Well, what we do in pharma, which is a very unique industry, is that we're a very regulated type of industry, right? And so there is no way that we can let to automated systems to do everything. There is always a human in the loop. And so that's obviously that human in the loop now will be able to do more in less times. And obviously they bring in their knowledge, the subject matter expert knowledge, into this process, and we'll be able to potentially enhance the way we do this and how do we, keep fine-tuning these models to be better at what they do. But definitely, in the foreseeable future, we don't see that fully automated where there is no humans. There will be always a human in the loop.
I think financial services is very similar to that.
Yeah.
Thank you, Juan. That was fantastic. Really appreciate your time.
A pleasure.
Next, to realize the promise of autonomous agents, data has to come first. Here, to guide us through how to build strategic, scalable data foundations, is Ranjit Chacko, Senior Director of Data Science at Oracle NetSuite. Welcome, Ranjit.
Hey, how's it going?
Very well, thank you.
Good to see you.
Yeah, you as well. So you oversee the teams within NetSuite that look after the financial and accounting, markets, operations, and you obviously have lots of introduction of ML methods and using that to automate things. But can you hear this? No, it was off. Is it on now? Hey, here you go. So, within your teams, you're obviously seeing into thousands of businesses. What are the patterns that you're seeing in how they are using their data? What are the challenges with their data? What's surprising you? And why are traditional methods not sustainable?
Yeah, so one of the biggest problems we see is just data being stuck in silos, right? So, a business might have, many different systems where they're storing the source of truth for what their business is doing, and it's really hard to get a global view over what the business is really doing. And then on top of that, the data in those systems might not be accurate or up to date, and so it's really a huge challenge just to bring it all together and make sure you have not just a complete view but an accurate view of your business.
Okay. And why do you think those traditional methods of doing that are just falling short so often these days?
Yeah, so I think again it comes down to having these silos, and so if your data is stuck in all these different silos, there's a lot of overhead involved in just connecting point to point, just getting everything into one system, from one system into another, making sure that it's accurate once you've brought those together in one place, that they're representing things in a similar way. So that's where a comprehensive platform like NetSuite can be useful for a business, right? Where we've got one platform that covers different areas of your business. So in your operations, like finance, HR, sales, supply chain. So using a platform like NetSuite, lets you get that consistent data foundation where you're not just unify the view of your business in one place. It's all modeled in a consistent way so that you can interpret it in a consistent way.
Okay, thank you. So yeah, consistent data, that's obviously a very key element around what a company needs, both to just manage these things and introduce new tools. Especially with the pressure of adopting AI these days, that's a critical factor. What are the other sort of key critical elements that you need in terms of your data to exhibit so you can employ AI sufficiently and efficiently?
Yeah, so I think, especially with agents, I think one thing that's going to be very important is on top of that foundational data is to have a semantic layer that can provide the meaning of the data to agents so that they can answer questions with the correct context about what that your finance data means, what your HR data means, or whatever your operations you're trying to automate are.
In terms of that semantic side of things, how do you mine that meaning from the data? Obviously something like NetSuite, there's standardized patterns that you can utilize for that, but does it still evolve to just those patterns or just asking people?
Yeah, I think part of how you expose it to an LLM, for example, you're going to be using techniques like RAG, right? So I think the scope of the data for a platform like NetSuite is going to be so large that you're going to want to make sure that you're retrieving at the query time the context and the semantics that are relevant to your users' queries.
Gotcha, understood, thank you. Given that you look across so many different companies that use NetSuite, can you share some examples of how companies have transformed and sort of gone on the journey of taking their data from a liability into an asset, and sort of what the key steps on that journey are?
So I think an example of something that we do for our customers is products like that assist controllers in speeding up the close at the end of the month by automating the detection of anomalies in their books. We give people tools like a product called Text Enhance. So basically everywhere you have a text field, we can help you automate the generation of the text that you would have to normally handwrite in those fields. Really, from the side of NetSuite, we can do a lot for you by automating your business operations using AI or machine learning.
Mm-hmm. And I mean, and that would be specific for each business, or does it adjust itself to the business that's using it?
Yes, I think that's one of the unique things about NetSuite is we have customer data that we can basically help you use your data to automate your business processes, in a way that's your data is never leaving your system, it's never leaving Oracle, and it can basically be personalized or customized to your business.
Got it, thank you. So you break down the silos by making sure everything lives within NetSuite and bringing it all together. We standardize the data through parts of the tooling that you have, and then you enhance it further with some of the machine learning and the AI capabilities that you've got within NetSuite. Does that get you to the point where you can go, all right, now I can bring my own mechanisms to that and my own machine learning or AI components to that you now have data as an asset?
You mean as a customer?
As a customer, yeah.
Yeah, so I mean, one of the big parts of NetSuite is it's very extensible. So there's a large partner community for NetSuite. And so, for example, we have an API that we expose in our SuiteScript extension language that lets you make a call to an LLM that's hosted in OCI. And so there's a lot of partners building features and customers using that extensibility.
Okay. And do you see people trying to start on that journey before they're ready? So if the data's not quite there?
Yeah, I mean, of course that can happen. I'm sure you've seen it too. So I think, but yeah, it's important to set that foundation first, before you go on to delivering, even analytic models or predictive models or AI. I think sometimes some of you may have seen before data science hierarchy of needs, and at the very bottom of that hierarchy is data.
And you've got to have good data to have good AI.
Exactly.
Got it. So again, because you can see across so many different businesses, what's your most controversial opinion about where enterprise data science is headed?
Well, I don't know if it's controversial, but I mean, I think, there's a lot of talk about automating away data science, but I think it's still, what LLMs can do is still pretty limited, right? I think when you start drifting into niches that there's not a lot of support for in the data that's been used to pre-train these models, they're going to start to break down. So, but if you're focused in on things that the LLMs have been really pre-trained to do, they're gonna do well. So you really need to think about what LLMs are good at and what they're not good at.
Okay, yeah, interesting. And then build evaluations and sort of really try and work out what are they good at and what are they not good at? Because I don't think you know until you try sometimes with these.
Yeah, exactly. I mean, I think when you start down an AI initiative, I think there's two key phases to think about. One is ideation, and I think it's important in the ideation phase to bring together a group of people that crosses functionality, data scientists, domain experts, engineers, and really this is a group that should have strong priors about really what is likely to be successful and useful. Data scientists alone might pick something that's easy to model, but not much value to the business. Someone from the domain side might pick something that could be useful if it was possible, but maybe it's not actually possible.
Yeah.
But then once you come up with an idea for something to do, it's still only a hypothesis, and then just like any kind of scientific enterprise, you need to evaluate that hypothesis and test if it's true or false.
Yeah, and continuously evaluate it, right?
Yes.
Because it might be true today, it might not be true tomorrow.
Correct. Yeah, data drift is a problem, and so building a machine learning product is more than just building the model. There's a whole layer of infrastructure that needs to be built around that model or whatever that random component that is in the middle. that whether it's an LLM or that's been pre-trained or a model you built yourself, there's going to be drift in the data that goes into it, and you need to manage that change.
Great, thank you. Does NetSuite have any other tools that, and mechanisms to help continuously improve the data?
Yeah, so I mean, we're building features that help customers manage the data quality, right? So I think, for example, with automating, helping controllers automate close of their books, right?
Mm-hmm.
So this is something users do already, but because the data that goes into NetSuite is the source of truth for their business, but we want to do whatever we can to make that easier.
Yeah. Brilliant, thank you. Those were all the questions I had. Are there any questions from the audience? Yeah, there's one online.
Yeah, we do have one question, if that's okay, Ranjit. So what kind of team do you need to deliver AI, and how does that differ from a conventional software development team?
Yeah, so we started talking about that just a little bit in one of your questions. So it's really important to have a cross-functional team to deliver an AI product, right? So it's I think the thing that a lot of people lose sight of is that an AI product is not is very different from your conventional software that you might build, because there is this intrinsically random component in the middle, and so the role or the skill set that you need to manage that component is typically going to be with your data science team, but the data science team isn't enough to ship that model. There's a whole layer of support that needs to be built around that to deliver it into production, keep it running reliably, and to give data scientists the tools they need to manage things like data drift, because the world is going to be changing underneath that model. And then on top of just the technical aspect, you're going to need domain experts that can help you make sure that you're building the right thing that is actually useful for the business or for your customers.
Brilliant, thank you. I think we are, one question from Punit.
So, Ranjit, so you talked about the contextualization. It's kind of like vertical contextualization of the fields themselves, and it's really cool in terms of I completely understand the value proposition of silos and trying to bridge them. What about horizontal contextualization? I mean, time series, of course, there is a horizontal context to time series. Have you guys had any thoughts? What are your thoughts on how do you do that?
Yeah, I mean, one of the propositions for NetSuite is sweetness, right? So we like to talk about how, if you have NetSuite and you fully implemented all of the components, there's benefits that you get from having both your finance and your sales in there, and your HR and finance, right? And so it's really going to be useful to be able to have that global view that says, it can say, look at sales, and then not just tell you about what's happening within the sales team, but how it impacts your finances. So, understanding the kinds of user questions that they might have that span modules would be a key part of how you decide what to retrieve at query time.
Fabulous, thank you. I think that was the last bit we had before lunch. Is that right? So
Yep.
yeah, let's get out of the way of people for lunch.
Lunchtime. Awesome. So yes, we will take a break for lunch now. We also have a demo room down the hall on the left in the conference room if you'd like to see our agents live in action. And we'll meet back here at 2:30.
Let me.
Next, we want to welcome to stage Bharathi Ramachandran, Director of Data Science, and Adam Cahill, General Manager at Kinetic, both from Sanos Health. They'll explore how causal AI agents are enabling real-time precision engagement in pharma. Welcome, Adam and Bharathi. Adam, we're good to go.
All right. Thank you very much for having us. You can go to the first slide in the show. So Bharti and I, we work at a company that I once heard described as a pharma company that has everything except the molecule. So Syneos doesn't develop drugs, but pharma companies hire us to do just about everything else that they might need to do, from running clinical trials and then all the way through the entire commercialization process. My job is in Kinetic, which is the data and insights platform for our commercial business. And where I sit at the bottom of the chart, we see all the data flowing in, and pharma commercialization ends up looking a lot like just a really complicated marketing mix challenge. The programs that we run can often include dozens of different specialty tactics. They all need to work together to drive an outcome. The outcome is a doctor writing a prescription. So you guys, that will sound a lot like a good challenge for Causal AI. And that's really what led to the beginning of the partnership that we have with causaLens. Next one. I also sit on the commercial leadership team. So in that context, one of the things we do is make decisions about AI investments. And from that vantage point, you start to become aware pretty quickly that most companies have really had underwhelming results so far. So the data here is from BCG. I feel like I've seen this kind of story in a lot of other places. So something like 3/4 of the companies haven't yet generated any value from their AI initiatives. And our goal is pretty simple. We want to put ourselves in the position to be on the 4% side of the chart and make decisions that help us create value. Next slide. I'm going to run a theory by you about what's going on with all this sort of lack of value statistics. And I think it could be that the mental models that we're using to understand AI are too limiting, and that's leading to a lot of ideas and a lot of initiatives that probably aren't ambitious enough to be able to create value. So you probably see these kinds of things the same as I do. You're the pilot and AI is the co-pilot. You're the driver and AI is just the GPS that helps you get where you're going faster. My favorite one is the magic wand. So AI is a magic wand, but you're the wizard that controls it. And all of these are just different ways of saying the same thing, which is that individuals are in charge, and what AI can do for us is basically just enhance what we can already do. So I don't think these analogies are necessarily wrong, but I do think that they're too small. And it starts to make some sense to me that if this is how so many people are thinking about AI, lots of the first round of initiatives, they're basically about making individuals more efficient. But the problem with that is even if everyone in a company becomes, 10% more efficient, or let's say 20% more efficient, I still don't think that adds up to something transformational. And at least not in the way that I imagine a board of directors is expecting their AI investments to turn out. So if the goal is transformation, these kinds of analogies are probably the wrong starting point. And it's like that saying, like, you just can't get there from here. Next slide. We kind of ran into this and we experienced this firsthand. So Bharti and her team, once they built this set of causal optimization models that they believed in, the next question for us was, well, how do we make this just the standard way that we work for everything we do? It's not like we want causal answers, but just some of the time. Like we just want to do work this way. But we do probably thousands of programs in a year. And if you think about the co-pilot approach, the idea that we could somehow use AI to just make all of our individual data scientists more productive, it really can't solve a problem on that scale. And there's no number of data scientists we'd be able to reasonably hire that could solve the problem either. Next one. So this is how we, sort of came into the world of agentic AI. And this is a world filled with many white papers and think pieces about the future. And honestly, the long-term implications of an agentic world are hard to grasp, at least for me. But working with the team at causaLens, we took what I think is a really practical but an important first step into this future. Next one. So our team's built an agentic data scientist that's using the causal models we built to generate optimization recommendations. And Bharti's going to tell you the specifics of this in a minute. I'll just focus on what I think this means for us as an organization. And if you look at a couple of the example questions on the screen, in the real world, these are the kinds of questions that could honestly take weeks to answer, because we don't have data scientists just sitting around waiting to answer questions like this that come in from business partners. But what this agent has let us do is start to work towards a path that actually just creates a different way of working. And it's a way of working where the business people like me, have access to data science really on demand, and where every optimization question has a causal answer. And we've effectively been able to scale the impact of the data science team almost without limits, at least for this particular kind of question today. Next slide. That brings me to something that I heard Darko say not too long ago. And the idea was, instead of thinking about AI as a co-pilot, to start thinking about the ability to create autonomous workers. And I found this to be a really big idea. And just a better starting place, a better mental model to understand what the potential is in front of us. And just think about, if you're starting a new initiative, the difference between starting with the question, what would I do if I had a co-pilot, and the ideas that come from that, compared to the ideas that come from, well, what would I do if I had an autonomous workforce? And we've found that thinking this way has really raised the level of ambition we have with the investments that we're pursuing. And that ultimately, I think, is what leads to real value creation. Next one. So I'll close my part of this just with a simple framework that we're using to guide our approach to AI, and sort of how we're thinking about what decisions we make that get us in that 4% of companies that actually are realizing real wins from their investments. So we absolutely have a whole portfolio of initiatives, with generative AI. And within those, what we're trying to do is make sure that we're solving the right problems. And what that means for us is problems that are big enough to actually be worth solving to begin with. And then problems where we have some form of data advantage to work with as kind of the raw material. But then, that space is really crowded. And so we've also made real progress and a commitment to Causal AI with this partnership. And there, what we're doing is pretty simple. We're answering the most important questions we have when it comes to driving performance. So what's really working and what do we do next? And doing that not some of the time, but all the time. And then finally, wherever we can, we're looking, to scale capabilities agentically and thinking much bigger, really as a result of this partnership here. So Bharti, I will hand it over to you, my friend.
Perfect. Thank you.
Thanks, Adam. So I'm going to take us through how this strategy at the company level really translates into the tools and solutions that we're exploring and building at Syneos. As Adam highlighted, there is a gap between the investments we're trying to make in AI and the tangible impact that it can actually deliver. In pharma engagement specifically, the gap doesn't just look like failure, it actually shows up as multitude of systems that are just busy without clear direction. So there's a lot of outreach, a lot of metrics and KPIs that are being tracked in dashboards, but there's really no direction around what's really moving the needle. So that disconnect is especially visible in the way that we engage our healthcare providers. And that's where activity doesn't always lead to actual outcomes. And this is the challenge that we set out to address with Causal AI. I will walk through how we built a precision optimization framework that's focused on scaling ATP engagement, trying to close that gap between what we do and what actually works. So from a traditional data science lens, we have seen engagement in pharma evolve. First, from very rep-driven engagements and outreach to more omni-channel execution today. And what this brought is really a lot more data, but still has not made us much smarter. And I think one of the key limitations is that most of our measurement frameworks today still are focused on correlation-based associations. Still haven't gotten us to whether specific engagement is really driving a change in prescribing behavior. So for example, by sending an additional email to an HCP, are we actually changing their prescribing intent? Or was it just an extra touch point? So this is the kind of question we really want to be able to answer. And without a clear way to isolate the impact, we're limited in our ability to further optimize these engagements. And that's why we shifted our focus from more a broad exposure-based targeting to more causally informed engagement. And that meant understanding not only what had happened, but also what worked and for whom. And that's what we mean by precision optimization today, and where most of our efforts are focused. So we broke our problem statement into a structured approach that aligns decisions along 3 different verticals, starting at the campaign, down to the channels, down to an individual ATP or ATP segments. And we did this because truly precision really needs to flow through across all the levels and cannot be siloed. And it has to show up across these 3 different levers. At the campaign level, we're able to ask questions around what's really driving causal impact and what's the uplift looking like when we have specific targeted activities in our campaigns. And this helps us assess the effectiveness across brands, across regions, and course correct in real life. At the channel level, we identify which tactics are high leverage, the ones that are driving meaningful lift, and the ones that are just burning the budget without actual impact. And this allows us to cut the wasted spend and rebalance the channel mix toward more high leverage channels. And finally, at the HCP level, where precision really comes to life, we are able to determine what kind of channels and the sequence and combinations are really most effective for individual providers or ATP segments provided, given the data. And I think this is where data science really becomes field strategy, enabling individualized action at scale, aligning both to outcomes and taking into account real-world constraints. And structuring our decisions across these layers has helped us think about our work more cohesively, whether we're making national campaign level decisions or planning out local outreach in the individual districts or territories. And this isn't just about adding more layers of insight, but really structuring our decisions in a way that's repeatable, explainable, and scalable. So when we applied this framework in practice, we built causal inference models across multiple of campaigns, specifically designed to estimate that incremental impact of each engagement, isolating the effect of various channels, adjusting for known confounders at the ATP level, at the region, at the territory level. And looking at specific brands, we were able to use the model and understand and quantify the 8% uplift in prescriptions that are driven by targeted activity. We also learned that not all channels are created equal. So face-to-face interactions have typically been most effective, and that is the intuition that a lot of our campaign reps have. We realized that face-to-face with sampling drove a lot of the outsized results at the campaign level, but when we actually zoom in and look at it at individual ATPs or ATP segments, there is really a different channel mix that's driving that behavior. And these kinds of learnings have helped us optimize how we think about population-level channel mix and match individual ATPs' targeting strategy. And this allows us to move from more broad-based assumptions and be able to test these theories in our data and be able to make actions that's grounded in strategy from ATP behavioral concepts. And I think what's really important is also that it's not just analytical insight. We're able to inform strategic enablement across our commercial operations. We used our causal outputs to inform and optimize some key layers and core areas of field and campaign strategy. First was prioritization. We used causal estimates to identify high-value ATPs based on their potential to respond, given their prescribing potential. And this allowed us to shift from targeting strategy that's just based on volume or decile-based targeting to more impact-based targeting. Second is allocation. We're able to guide how we deploy our field reps by geography and balance the channel mix based on predicted ROI. And this allows us to move from deploying reps where they're available to actually where they can actually drive meaningful lift. And third is campaign investment. Third is campaign investment optimization. So by running different scenarios based on trade-offs that evaluate cost as well as expected impact, under different tactical choices, we're able to better inform whether leaning in more on face-to-face reps or doing a more digitally focused campaign is going to be more effective. What kind of strategies and strategy mix is going to give us the best return within the same budget? These simulations give our commercial teams the confidence in how strategies will actually play out in the field before they even go to the field. We're also able to use the causal insights and are exploring more fine-tuning our message content and the message delivery as well, sequencing the interventions as well as obviously personalizing it as much as we can at the ATP level. Together, these capabilities have really allowed us to build more prescriptive playbooks that align with commercial implementation and that's backed by causal impact. And as Adam said, to really see the value of these models, especially in pharma engagement, we need to be able to embed our insights past just dashboards and be able to incorporate it within the existing workflow, especially in an industry like ours where there is traditional thinking, there is a lot of intuition-based decisioning happening today. How do we take the insights we're seeing from our data, the insights that we're confident about, and be able to incorporate it into daily decision-making? And that's what really led us to exploring data scientists, agentic data scientists with causaLens. And they've helped us build this agent that's powered by our causal models. And it allows our commercial users, specifically brand leads or campaign strategists, to ask complex optimization questions about what's the best engagement strategy for the top 1,000 HCPs, as well as incorporate known real-world constraints such as campaign costs, as well as channel availability. The agent interprets the question, queries behind the scenes, and delivers an actionable answer in minutes. And as Adam said earlier, this isn't just about making individual users more efficient, but really the agent is about scaling that thinking, bringing causal reasoning closer to the decision makers in planning and execution of campaigns. And I do think it extends the work that my data science team does today. It moves us from point-in-time analytics or reactive analytics to empowering our commercial teams closer to the data. As I reflect and wrap here, I think what we have built is really a foundational step toward enabling causal decisioning and bringing in that elevated thinking in how we decide our campaign strategies into the ecosystem of commercial pharma. I think there is a lot more to do here as we look at change management, as we help train our commercial leaders and commercial teams on how to incorporate these types of agentic workflows, these kinds of insights that's really might sometimes even contradict their intuition, but really help them become more comfortable about the insights that we might show them. So I don't think these kinds of models or workflows should be built in silos, and that's one of the biggest, I think, learnings we have had in incorporating and bringing in our commercial teams onto this development journey with us so that we can build systems that are more applicable for them. Thank you.
Thank you, Bharti and Adam. The future of pharma is clearly causal. Next up, we have a fireside chat with Punit Gupta, Head of Data Science at Crowd. Punit will show us how AI agents are accelerating marketing analytics with precision and scale. Let's roll the video.
Hello everyone, this is Petros from causaLens. I am with the data science team here. We are working on developing and deploying agents for our customers. We also make sure that they get economic value out of it and they can see the benefits of the revolution in agentic AI. With me today is Punit. Good morning, Punit. It's great to have you here. Before we start the conversation, how about you introduce yourself and the company Crowd that you're working at?
Brilliant. Thank you, Petros, and thank you, causaLens, for this opportunity to talk at this conference. My name is Punit. I'm the head of data science at Crowd. We are a marketing agency. We work with some of the leading brands on a global level, talking about marketing effectiveness. We solve the marketing effectiveness challenges. We bring strategic and tactical methodologies to guide them towards growth. All of this time, ensuring that it's data-driven and utilizing advanced analytics principles. So, yeah. Petros, cheers. Thanks for having me over, yeah?
Amazing. So, we've been working together now for almost a year, and I think we have done some amazing stuff together.
Oh, yeah.
What I want to focus on about today is our latest project, which is about custom data science agents. But in particular, our team has been working with Crowd, with data scientists at Crowd, to develop a custom EDA agent that helps Crowd with their EDA tasks in various projects. Before we dive into specifics, I want to understand what urged you and Crowd to start experimenting with data science agents so quickly.
I think the first thing that I want to kind of address here is the problem that we face as a team. So working with clients, their challenges always grow. There's never a point in time when you have less workload or as such, right? So scaling data science is massively challenging, right? And that's kind of the key area that we wanted to focus on. You will sometimes see that, with our clients, more often than not, they might have massive projects that's coming in. But the general methodology for us to kind of solve this particular problem would have been to hire someone contractually at a very quick turnaround time, or sometimes even hire a freelance agent, right? Now, the challenge with this specifically comes in from the point of view that we are a marketing science team first, right? Hiring a data scientist or a freelance or even a full-time data scientist takes time. Training takes effort, but we want to be able to deliver at the speed at which our clients require us to be able to deliver, right? And this is very, very challenging. Now, when we are talking about agents and why we wanted to go down that particular route, this was a core problem I wanted to solve. I wanted to be at the space at which my clients wanted projects to be delivered or work to be delivered, right? What do agents do specifically here? Obviously, they do automate a lot of the workflow, but they do something a bit more deeper, a bit more insightful. They are able to take context into play. We are able to feed in our domain expertise, our marketing expertise. We are also able to leverage expertise across the channels. Like I said, we are a marketing agency. So we have deep marketing expertise in every channel that we function in, right? And we're able to bring this context together within this agent. What is this doing for us? It's minimizing that specific training time, and that's specifically one of the reasons why we wanted to be able to use agents in our workflow on a day-to-day basis.
Oh, this makes absolute sense. I have had some past experiences in consulting roles, and this is definitely the case with unexpected and strict deadlines, which always cause a problem.
Yeah.
Before the option of adopting data science agents was on the table, did you end up hiring a lot of freelancers? And in cases where you couldn't do that, what were the implications for Crowd and the projects you were working on?
One of the top offerings that we have at Crowd is that we have something called as a Crowdy network. So a Crowdy network is freelancers across the globe who we would tap into at times when we wanted to have a project and we didn't have the scale within our specific teams, right? Again, like I said, the problem continue to remain that they can't bring in the same level of domain expertise as someone who's full-time and in-house within our agency. So that was our general approach, but we want, like I said, again, speed is absolutely critical at an agency, and more often than not, you want to be able to deliver quick. If you deliver an insight too late, it's already useless. It can't be actioned upon. So timing is absolutely critical, and that's where we were missing out. And that was generally the problem. I think this is a problem that most agencies around the world face now.
This makes absolute sense. I understand also, like, even when you hire a freelancer, they still have to get onboarded. There's going to be time. They need to understand the context. They need to understand how you're working. So even though you may end up delivering the project eventually, it might be not the highest quality, as high as it would have been if it was an in-house data scientist, or the margins are also lower, right? Because you have to hire ad hoc, and there's a lot of cost that is associated with doing the process, vetting them, and so on and so on. Now, as we mentioned in the beginning, the causaLens team has already deployed one such custom agent for Crowd, which is the EDA agent, as we call it. I understand your team has started working with the agent. So what are some early, let's say, changes that you're seeing, that you have started to see slowly in your day-to-day operations with this EDA agent now in your hands?
Oh, I mean, productivity is at the top of my mind right now, right? I'm just going to give a quick insight into what your EDA agent is doing right now. So your EDA agent is focusing on removing the mundane tasks from our day-to-day works. One of the steps it's doing is cleaning data. If you ask any data scientists around, they would tell you we spend 70%, 80% of our time cleaning the information and then exploring everything that's the data is able to tell you. And this is a time-taking aspect of our work. Now what the ED agent is able to do for us is remove this process completely. All we are now focused on is drawing insights, not in the process of building the pipeline for cleaning data or mixing up data, joining them. These are all very, very mundane tasks, right? Once you are able to remove this process from our everyday workflow, what's able to do is allowing our data scientists to focus on the higher value tasks, right? Okay, drawing insights, that's very, very high value work, right? Or building the models itself. Now that's again challenging, sometimes beyond the scope of generally an agent itself, where you need these domain expertise as well. But the main focus here is the high quality work that our data scientists are able to deliver. They are now delivering more per pound or more per dollar than ever before. So that's increased productivity.
That sounds amazing to me. We've been working on these agents for quite some time now. I realize that there's now, a few data scientists within Crowd that are using this technology.
Mm-hmm.
But if we were to, have more data scientists or more people within Crowd adopt this kind of technology and potentially also gain these productivity improvements that you're describing, how do you think this would affect Crowd on a strategic level, in the next 1 to 2 years?
What I would say here is, yes, data scientists using it is always gonna make them deliver higher quality work, but this is a bigger implication here, right? When you are able to deliver high quality data science work through agents, the use case is not only data scientists, the use case goes beyond it. Like I said, we are an agency, we do marketing for PPC, for social, across different channels. They don't really know how to do data science work. They need insights all the time. They use data all the time. But using these agents, what it's allowing us to do is democratize data insights specifically. But also, once we move into a space where agents are able to take up a lot more of this particular workload, that's where I see the data scientists being able to focus or oversee the complete workflow of a project from end to end, from cleaning, from processing data, to insights generation, to building advanced analytics tools. Talk about media mix models, talk about advanced attribution models, right? And now these models can become customized to the clients based on the industries that they function in, or for any bespoke use that they need it for. So able to orchestrate this whole workflow from data ingestion to insight delivery, it is going to change how, not just Crowd, potentially how agencies are going to be functioning in the future.
Now, this is also our long-term plan, to be honest. We already delivered the EDA agent. I think we're also scoping right now a few more agents that are going to be tackling, different parts of the workflow which are currently unaddressed. But at the same time, causaLens has been working on, that orchestration layer that you're talking about, right? So we're envisioning, companies having, a bunch of custom agents that are tailored to their expertise, to their internal workflows and so on. But eventually you would need an orchestration layer that would just be able to pick out, which custom agent is suitable for which task. Will also be able to evaluate the, the current output and decide whether to proceed further or not, and potentially, decide whether, a human needs to be involved and they need to provide, more expertise, or, give directions as to where this long-running agent should go.
Oh, that's exciting. I mean, we're already in this exponential growth in terms of when we talk about data science as a field itself, or artificial intelligence itself, right? It's changing, and the pace at which it's changing, we are also catching up with it. Absolutely. I don't see a time. I do see a time where a lot of this workload that humans do pick up will be taken over by the agents. The human aspect comes from intelligence, the domain expertise that we would be continuing to provide, being able to oversee the whole orchestration, ensuring the quality of delivery through these agents. So the work structure of what a data scientist does today
We are glad to hear that our efforts are being appreciated. All right, Punit, thanks so much for being here. Thanks so much for sharing, how you think about this, how marketing agencies think about this, and what problems they're facing, and how agentic AI can potentially, help them become more efficient, more effective, and potentially also, help the human workers, become much, do the more interesting stuff, the more intellectually challenging stuff, and not just stuff around coding and so on.
Absolutely, yeah. Thank you so much for the opportunity that you've given me to talk in this particular show. I mean, it's such exciting times, isn't it?
Perfect. Thanks, everyone.
All right. Thank you to Punit. We have an incredibly exciting session next. It's not every day you get to hear from one of the most influential minds in causal inference. Please join me in welcoming Professor Imbens, Nobel Prize laureate in economic sciences and professor at Stanford University. He'll be in conversation with Max Sipos, co-founder and CTO of causaLens. They'll discuss causal reasoning, automation, and the future of rigorous data science. Professor Imbens, Max, welcome to the stage.
Thank you so much, Guido, for coming here today. Obviously, Guido is a Nobel Prize winner, a professor at Stanford. Pretty much reached kind of peak in academic career, but he also works with a lot of industry as well, and so I think that's really fascinating, right? That you kind of have this experience working with industry partners as well. And so I'm very curious to hear your perspective on data science as it's currently applied in the industry, and sort of problems and things like that you've observed.
Sure. Yeah. So I actually started kind of working with industry when I moved here to Stanford in 2012. Up to that point, I'd really largely been staying within my academic position, working with students and other academics. The last 12.
Sorry, Guido.
Oh, sorry.
Yeah, no, just
yeah. So last 12 years, I've worked a lot more with people in industry, and it's just been great. It's been really interesting to see the problems people in industry are working on, the questions they have there, and it's been really inspiring for my own research, and it's been great for the students I work with. A lot of them have done internships at various companies, and just getting them motivated to work on real problems, on problems where the people are going to be directly interested in the solutions and the answers that they come up with. And so I think, and I see that sort of in the data science, the Stanford Data Science, that I'm directing at the moment. I see there it's been incredibly helpful for both sides, kind of for industry as well as academics, to get these collaborations going, to make sure that people work on interesting problems, on problems that are relevant, kind of for both for private organizations as well as society as a whole.
And what would you say is kind of the challenge in data science? What remains kind of difficult?
I think there's still a lot of challenges. Actually, this morning I was at a robotics conference at Stanford, and there they were sort of one of the presentations was about teaching robots various tasks, and they were initially doing that essentially by hand, kind of task by task, and they had the graduate students kind of teach these robots different challenges. But because the problem with that is it doesn't really scale. And kind of if you kind of think about the way the large language models have become so successful, is that a huge amount of data
to train them and to become better. And you can't really replicate that by having the students kind of by hand teach these robots each of these individual tasks. So what they were working on there was trying to exploit all the information that is in YouTube, all the videos that are there, and using those videos to directly train the robots to learn new tasks. And so one of the challenges kind of in general is getting the right data for exploiting, for leveraging all these AI tools. And so in language settings, we've done a lot of that, but there's other settings where we have a huge amount of information that humans use all the time and that humans use very effectively, but we haven't really been able to get the AI to use quite as effectively.
And obviously, your Nobel Prize was for causality, right? And so, how do we get machines to learn causality? What's the problem with that?
Yeah, because that's a big challenge, and I think there's still a lot of things that we don't do very well. But it seems at some level that these challenges are very much the same as ones we've managed to address in the past. For a long time, these things, it seems like there's these boundaries where we can't really get these thresholds, we can't really get past. But eventually, we will get there. We saw that kind of with computers playing games, with playing chess, with playing Go. And so at some point, they got past what we thought was going to be incredibly hard. And so you see that in data science as well. Now we're managing to automate many of the tasks already, but there's still a lot of things where we feel there's creative parts that we don't do very well, and where we can't get the data at a scale that allows us to automate these things. But then suddenly people have new insights and figure out ways of getting past these barriers. One thing that I think is very interesting, recently read a paper by some Stanford authors where they were trying to use large language models to get at causal effects. And so they were explicitly using these large language models to predict the results from randomized experiments. And so the way they were doing that is setting up creating a bunch of artificial subjects for these experiments and training them kind of on past behavior. And then they were actually running an experiment directly on these artificial humans, where some were exposed to one intervention, some were exposed to other interventions, and then they were analyzing the data coming out of that, just as you would analyze a randomized experiment. And so that actually worked incredibly well. Over a bunch of experiments, they got a correlation between the effects estimated by the large language models and the true effects from the estimated on the experiments, kind of taking account of the noise in there. The correlations of about 0.8. So they seemed incredibly impressive. Now, in practice, it wasn't quite as impressive when they looked at these experiments, when they asked experts what they expected the result of these experiments to be. They also got very good results. The experts could also predict what these experiments were going to do with a correlation of about the same, around 0.8. So these were really not all that interesting experiments. These were things where pretty much everybody knows what to expect. And so the challenge clearly is doing this in settings where we don't have any idea what to expect, and seeing if we can still get the large language models to do well in those cases. And that's going to be a much harder challenge.
Right. So you're saying the experiments were basically in sample, right? So they were kind of testing the questions that people, sort of the language models already knew the answers to.
Well, no, they looked at some experiments that hadn't been done yet either. So it was fair in that sense. It wasn't true for all of them, but in the end, they validated also in experiments that hadn't been done. But even so, these experiments were still of a very simple type, where experts had very strong priors also what the results of the experiments would be, in a way that made them much less interesting than they could have been.
Yeah, and so I guess causality is usually about figuring out this counterfactual, right? A reality that is not that's not our reality, right? And so how, you know, how do you do that maybe with language models, and what are the challenges there?
Yes, so at some level it is always about what the things we don't know and the things we can't directly see. On the other hand, sort of if we actually do experiments, if we confront people with these new interventions, with these new environments, they make decisions based on their own experience, based on their own guesses at what the world looks like, and they take actions based on that. So that doesn't, the individuals are in some sense solving predictive problems. And so if we can get the large language models to do very well on that type of predictive problems, taking individuals to environments they haven't seen, but doing that in a way that captures kind of both the uncertainty, but also gets things right on average, there's certainly some hope that we could get large language models or AI in other forms to do well in those settings. I certainly wouldn't bet against it. I don't think we're quite there yet, but I think that's certainly one direction we need to go to make these models more robust in changing environments and make them causally aware. Yeah. I guess one big application for language models is building autonomous agents, right? And especially, do you see a place or a role for agents in data science? Yes, I mean, it's clear that at some level we already have agents. We have all the software that kind of does things that we used to do, that people used to have to do by hand. But it's going much further now, and it's clearly getting to the point that the AI agents can do data science tasks that till very recently you would need students, you would need graduate students, you would need researchers to do, and they're going to help us in a way. And I think that's really what you see across a whole number of different occupations. They're going to enhance the abilities of humans to be very productive in an incredibly effective way, where it makes very skilled researchers much more productive than they would otherwise be.
Do you have a perspective on actually how to make agents more trustworthy?
Yes, well, I think that is a big challenge, and I think one of the things that makes that harder in causal inference settings than in the predictive settings, where a lot of the machine learning methods have been incredibly effective, is that we don't have the data that makes it easy to validate how well we do. In machine learning, we've had these competitions where there were common challenges, common data sets, and we could measure how well the different models, different approaches worked. And we could see kind of both the steady progress, we could see when there were breakthroughs that really changed how well we could do these things. And in settings where we're interested in causal facts, that's much harder. We don't have a whole body of experiments that we could compare to where we could use to validate new non-experimental methods for trying to get at causal effects. And so I think finding systematic ways of validating these methods and realizing when they're actually not working would be incredibly helpful in moving the field forward. And we can do some of that with simulations, and there's a lot of specific methods in specific settings, but we don't really have a systematic set of methods for that as we would like.
So if I understand you correctly, the agents are essentially taking actions, right? And the moment you've taken an action, you're kind of in the causal realm, right? You're no longer in sort of in a predictive space, right? And so there's some. Is there any other ways in which you can see sort of causality being key to building better agents?
Well, causality is in the end key for all decision makers. We're trying to look at the effect of what our actions are going to be, comparing different possible actions. So actually, this morning I was thinking about the session, thinking about what I was going to say. I was talking to my daughter, and she was actually asking, was there going to be any swag here at this conference? Because 2 years ago, when I was here, the causaLens had these mugs with various quotes, and I said, well, actually, I have a good quote that I should put on a mug for causality. So I brought the mug here, so I will read it. You can't really read it from there, but it says, Felix qui potuit verum cognoscere causas. So now, first question is, how many people here actually know Latin? All right, there's a couple of people. Now, there was I'm from the Netherlands originally, so I actually did have Latin. I did do Latin in high school. But there was a debate recently in the Netherlands where they should abolish Latin in high school because people felt it wasn't really all that useful. And then as part of the debate, someone said, well, but if you look at the earnings for people who studied Latin in high school, it's much higher than for people who didn't study Latin. Then someone else pointed out, well, maybe there was just a correlation. There wasn't actually any causal effect there. And there's a very direct mechanism for why these earnings would be high, because in Holland, the high school system is very tracked. So at age 11, you do these exams. If you do very well in these exams, you go to academic type high schools, which are the only high schools where you could actually study Latin. And so, conditional of having had Latin, you must have gone to one of these academic track high schools. And then it got interesting, because then there was a discussion about, well, how could you actually figure out whether Latin would have some value for people? And I could well imagine that it actually does. But I did it sort of felt very much like doing math. It was kind of like a puzzle. It was good exercise for kind of learning how to think and focus and concentrate hard on challenging problems. And so that's kind of problem that in econometrics we often try to solve, where you have these selection problems. The people who take Latin are very different from the people who don't, but you still want to get at these causal effects, and we use various techniques of the type I've worked on using instrumental variables. And so in the discussion, actually, someone suggested using some of those methods, using the fact that, even conditional on going to one of these academic type high schools, not all of them offer Latin, and which one you end up going to probably isn't really related to whether they have Latin or not, but much more likely to be related to which one is the nearest. So conditional on the nearest high school being 3 miles away, if that has Latin, you're much more likely to end up studying Latin. And they did actually find something that looked like it may be a plausible causal fact, much smaller than the original correlation, but something that was actually somewhat credible. And so kind of one of the challenges is that figuring out that type of strategy to actually uncover these causal facts in that type of approach kind of takes a lot of creativity. Kind of the way that's sort of typically done in my neck of the woods in economics is kind of people come up with clever ideas. And those tasks are often very hard to automate. But again, there was actually recently a paper where someone tried to have large language models do that. And kind of with a lot of prompting for that type of problem, they actually came up with very interesting strategies of dealing with these selection problems. So they kind of specifically looked at ways of estimating the returns to education, where again, kind of you worry about the fact that people who get more education may be different from people who get less education. And so the challenge was finding ways that essentially randomly assigned at least part of the education. And with a fair amount of careful prompting, the large language models actually came up with very creative solutions there, and very interesting things comparable from my perspective to the way good graduate students do things. So I think we're really getting to the point that we can use these AI agents in data science, not just to kind of do the simple tasks, but actually do the things that we traditionally think of as much more the creative part. And so we keep moving the bar there, what is actually creative and what these large language models cannot do. So now, just to actually finish that story, so what does the quote actually mean here? So it means that it translates as, happy is the person who can figure out the causes of things. So it's really suggesting that what causaLens does, what we all do, is we're really in the happiness business. We're trying to make people happy here by giving them these tools, giving them the methods for actually learning about these causal effects.
That's very interesting. And now that you said that agents can sort of design interesting experiments with instrumental variables, what's left for the humans? What do you think? How will we find happiness in this agentic world?
Well, so one thing is that this in part of the causal literature, causal data science literature, there've been a number of ways of trying to get at causal effects. There's randomized experiments that are very clear way of getting causal effects. But then there's more complicated, somewhat bespoke methods in settings where we don't have randomized experiments. And it could well be that there's more of these methods out there that we haven't really thought of. What's been interesting in the interdisciplinary nature of causal inference is that people in computer science have thought about these problems, people in social science have thought about these problems, and they do come up with different strategies. And that kind of suggests it would be hard to imagine that we're done with that, that there's not more ideas out there for actually getting credible ways of finding out causal effects. And so AI agents may well be able to do so. Another setting is for experimental design, kind of traditional experimental designs going back to Fisher and Neyman, kind of focus on these cases where we have a bunch of units, we divide them into two groups, a treatment group and a control group, and we don't worry about interference between these units. In modern settings, interference is very often intrinsic to these problems and is a big part of it. If Uber wants to know whether a different search price policy would change the way the market worked, they can't just assign some drivers to the new search price policy and others not. Because the effect of assigning some drivers to a different policy affects also the drivers in the control group. The treated drivers start driving more or less. That affects the competitive equilibrium, and you need to figure out the overall effect. And so dealing with coming up with good experimental designs in these settings where we need to worry about equilibrium effects and indirect effects is much more complex. And again, that is an area where I think the AI can be very helpful in figuring out how to design experiments there.
As a Nobel Prize winner in economics, do you have a perspective on how agents are going to change maybe the economy as a whole, or the labor market, or something like that?
Yeah, because there's a lot of economists thinking about that, worrying about that these days. And actually last year, it's very interesting, Darko Matovski, who actually won the Nobel Prize in October last year in economics, but earlier that year, I think in May or so, he wrote this paper where he argued that the effect of AI on GDP was actually going to be very modest over sort of a 5-10 year horizon. I think on the order of 1.6 of a percentage points, incredibly small. And so now he kind of hedged that a little bit by saying, well, in the longer term, it could be much bigger, but at the moment, kind of given that the set of tasks we do, if the set of tasks we do stays fixed, there's just a lot of areas where AI is not going to help. It's not going to kind of build houses. It's not going to harvest the crops. There's a lot of things where large language models just don't really do anything. There's a number of things where they do. They clearly help a huge amount in call centers, in making people answering queries in call centers much more productive. But it's a limited set of tasks where the large language models are going to have a big effect. And so overall, the effect is just not going to be all that big. Now, it could be that these things happen much faster, and then there is clearly a huge amount of scope for incredible disruption. Even if you go back kind of to the Industrial Revolution, there in the longer term, that was incredibly beneficial for society as a whole. But in the short run, and the short run lasted fairly substantial amount of time for generations. People suffered greatly as a result of the Industrial Revolution, the disruption that happened because the skills they had acquired painstakingly with a huge amount of effort suddenly turned out to be essentially without any value. And so the same thing can happen here, that a lot of the skills people have acquired may turn out to be to have very little value in the short run. So things can be incredibly disruptive, and making sure we're prepared for that, making sure we're prepared for people having to shift the type of tasks they're going to be doing is going to be the first order problem.
So Guido, I guess you're now on the forefront of both causality research and more broadly also AI research, and I'm curious to hear what do you think is sort of the next exciting thing? What are you personally excited about? What's sort of state of the art in your mind, and where do we go next?
Yeah, I think this is a very exciting time. I think there's lots of interesting questions. I think we're going to bring in a lot more different types of data and ask causal questions. I think clearly AI has been incredibly effective in answering predictive questions, but making sure, and they've done that with lots of different types of data and lots of different settings that traditionally social scientists haven't really looked at very much, where social scientists have often been very narrowly focused on causal questions in very specific settings. But sort of combining the type of data that are now available with the type of questions and expanding on the set of questions we're going to be asking, I think that's going to make for really interesting research for years to come.
Very cool. Guido, thank you so much. I'd like to open it now to questions from the audience. Anyone maybe live who'd like to ask anything? Maybe you first.
Hi, Guido. I used to be also an econometrician. So yeah, maybe I just ask one question. You mentioned about last year, right? Stanford AI Lab, they create lots of emulator to simulate the result for counterfactual, right? So that we can process the entire causal inference. So I was wondering if is it there a pipeline, right, or already exists for people like causaLens, they can push, right? All of your paper is about the causal inference theory. We can simply, once you publish a paper, it's all mathematical formula, and we can immediately use the image or whatever to connect your paper to the production, so that people can people they don't understand the formula, they can easier to use your pipeline. Is there a way or is it possible to do that?
Well, I think, thanks for the question. I think we're going to go somewhat, we're going to try bring these things, these literatures together. And so I think it's clear that it's that actually doing experiments the way we've done traditionally, and really going back to Fisher and Neyman in the 1920s, where these things would take a long time, and it would be very costly to actually do these experiments. I think it's going to change, and we're going to bring in AI agents as a way of speeding up the experimentation process. But we're going to need to make sure that that actually is robust, that it gives us credible results, and that's going to take a combination of theoretical work as well as very careful validation. And kind of doing a bunch of experiments to try to check that these things are actually working. But I think that's just a very obvious thing, that where essentially all the technology is there for doing that. So I'm sure that's going to happen very quickly.
Thanks, Guido, for sharing the insights. So I'm curious, like, could you share the? It's a very technical question. Could you share the two papers that you just mentioned?
Yeah, sure. Yeah. So send me an email, or I'll send it to Max, and yeah, I can share those papers. I think they're somewhere on the archive, but I don't have the authors' names quite ready at the top of my head.
All right, thank you.
Oh, Punit.
Professor Imbens. So I work at Cisco, and we do demand forecasting using Causal AI. And it was really interesting, the competition that I think you were involved with it with ADA Labs on inferring the right model, right? The ground truth structural causal model. And so I wanted to ask you a little bit about what your thoughts were from that competition. And then second thing is, do you think some of that could be agentified to get closer to the ground truth based upon what you saw?
Yeah, so let me kind of step back a little bit. So in general machine learning settings where we're looking at predictive questions, these competitions have been incredibly powerful. They've been incredibly effective in getting people to focus on these questions and improve the type of methods that we're using, whether that was for pattern recognition, kind of for these the digit recognition things. For causal questions, that's much harder. People have tried these things, and there have been a number of these competitions, but the challenge is that somehow we still need to put in some of the causal effects, because we don't really know the ground truth without putting that in. And so the challenge is kind of making these problems interesting enough and still knowing the answers. And what we need to do is come up kind of with systematic ways of doing that, and doing that in a lot of different settings, and making sure that we actually look at enough different settings is a big challenge. So we can kind of take one particular experiment and do things there and compare things to observational studies, but we don't know whether, even if we get it to work there, whether that's going to work in general in enough different environments. So once we get to the point that we can validate these things well, I think that would open up a lot of possibilities for improving the methods the same way people have done in machine learning in various forms.
Other questions from the audience here?
Hi, thank you again. It was very interesting. I had a question. You were mentioning about interdisciplinary approaches and how that could, further. So, for instance, I learned about, synthetic control and things like that. I'm curious what other interesting, like interdisciplinary approaches you've seen, and specifically thinking of, the way AI is moving and what would make it, novel and still useful in this world. Thank you.
Yeah, so I know the interdisciplinary part, the interdisciplinary aspect of this work is something that's very important to me. Very early on, when I was a junior faculty at Harvard, I benefited greatly from interacting with people in other disciplines. So at that time, I was in the economics department at Harvard, but I ended up talking to the people in statistics and some in computer science. And that was just incredibly valuable for me, kind of seeing the different perspectives people took, the different ways of thinking about these problems. And that really, I really benefited from that by ending up asking different questions, and that led to some of the research, my research that I'm most proud of over the years. And so now, kind of being in charge of the data science community at Stanford, I'm trying to build that type of community where I can get people from different disciplines taking different perspectives to talk to each other and kind of realize that sometimes some other discipline has actually has found insights that are actually very useful in other areas, but without talking to people in these other fields, they're not going to realize the gains from doing so. And so synthetic control is kind of one example of one of these methods that was actually that originates in economics. There's people like Alberto Abadi and co-authors that came up with some of the insights there. But then it turned out the computer scientists had very useful insights into those methods, and that's greatly expanded the usefulness of these methods.
I have one more question. Just like, do you think, so just like asking for some like recommended like follow-up reading or whatever, like just you share some of your opinions. Basically, is there some of the state of the art research or, like kind of like the way of doing practitioners so that we effectively integrate the world knowledge from language models when we are making causal inference? So for example, like the synthetic control example, right? Say if we are running a like geographical test to measure advertising effectiveness using synthetic control method. And the result came in as, like maybe the lift size is estimated by, maybe 3,000 more signups. Now, when we interpret the results, usually, right, like we say, okay, because of like the effectiveness of this this marketing channel, we drive this 3,000 extra incremental signups. However, in the real world, it could be also possible that there are many like confounding variables, right? Or just like some other causal like variables that are driving this 3,000 more extra signups. Like maybe the stock market is performing really well these days, or there's like a earthquake going on, or something else. Well, earthquake would drive down signups, hopefully. I mean, usually, but just like these ongoing world knowledge. They are like traditionally they're really tough to get like pull this data through like API or through like you need to process like news. But with a real-time kind of like updated large language model, hopefully these knowledge are already embedded in the language model. So I'm curious, like from your experience or your vision, like how do we best integrate such? Yeah,
sort of thinking about building bigger models to integrate these complex settings. is very important. So let me make that a little bit more specific. So when I was an undergraduate in the Netherlands, actually, I was soon an undergraduate in Rotterdam, and at that time they had a model for thinking about the economy as a whole, kind of the whole economic system. There wasn't a mathematical model. It was actually a physical model. There was a engineer, Phillips, would actually build a physical model for the economy that involved kind of a bunch of containers and pipes where water would flow through this whole system that would allow you to kind of predict what would happen if the government changed the monetary policy or changed fiscal policy or had some government policies. So somebody could change the exchange rates, but it could change different features of the economic system, and you could see what the effects would be on, say, the GDP for the entire economy. Asking an AI directly what the effect would be of one particular policy would be very hard. But kind of by having a model that allows you to focus on particular components of that and guide the AI to focus on the different steps to actually get there and build a causal argument for what the effect of particular policies would be, is much more likely to actually get you to answers that actually make some sense. Kind of, and that goes back to thinking about the way I described these experiments being done in this AI system, rather than ask what is going to be the effect of changing this intervention. Modeling a bunch of individuals and letting each individual respond to a particular environment is much more likely to be effective in giving you credible answers. And so using AI for these questions would require you to build complex models and break them down into different components, where each of these components themselves give you more credible answers. And so it's going to be very hard to actually get good answers out of these things without breaking it down into a number of different components, where each of these components it's much more likely you're going to get credible answers to all the different components.
Thank you, Guido. That makes a lot of sense. Yeah, thank you very much for coming today. It was a big pleasure. Thank you.
Yes, thank you, Professor Imbens and Max. That was an incredibly enlightening conversation. And now we will take a short break, enjoy some tea, and we'll meet back here at 4:30. and welcome back from break. We're delighted to have Tony Jabara, VP of Engineering and Head of AI ML at Spotify, join us for a fireside chat hosted by causaLens VP of Engineering, Ronald Hobbs. Tony will share insights on building some of the world's most sophisticated personalization systems.
Thanks, Jillian. Welcome, Tony.
Thanks, great to be here.
Yeah.
Thank you, Jillian.
Excellent. So obviously working at Spotify, huge product, lots of users. One of the things that I was quite interested in is, well, how do you see the difference in AI and AI adoption between a B2C type product and like Spotify and enterprise environments? You know, what makes each uniquely challenging or even uniquely rewarding?
Sure, yeah. I mean, we definitely have some enterprise level AI. We have AI for helping our developers and increase productivity in-house. We also use AI for partner integrations and AI for creators, which you could think of as a little like enterprise because, you know, you're working and providing tools for one of your customers. But then we also have a large consumer-facing AI offering, and it's very different because of the scale. So we've got things like AI DJ and our AI playlisting, and there you've got to run that for, you know, hundreds of millions of users. Right now we're in the 600 and such million monthly active users. So you can't just say, hey, let's let every user do deep research and we'll foot the bill. That gets very expensive very quickly every time they open the app. And so you want to get something that has the right ROI, and the way you measure the ROI is very different. Of course, on the enterprise side, you might say ROI means I save time, I can do some research more quickly, I can get a report done faster, I can, you know, save some data hunting, data cleaning, etc. Productivity, maybe somebody gets faster at PRs or code reviews or other types of things like this. But on the consumer side, we measure the upside really on our core business, which is increasing user engagement, consumption, and retention. So are you getting more users to stream more? That's the main kind of ROI numerator. And so performance matters there a lot, of course. You want to have good AI to do that, but you can't just throw in the most expensive models because you also have to divide by the denominator, which is the cost, you know, cost per token and things like that, and that can quickly add up. So you end up not always going for the most expensive AI model. You have to have the economics work out right, where you say, okay, I've increased streaming causally, let's say, but I can't afford to do this for 100 million users or hundreds of millions because it just costs too much. So then you say, how do I take a smaller model and maybe optimize it and distill it or fine tune it so I can do that at a better cost and even better latency as well, which is super important for our users, so that you can get something out at scale. And so that's one of the key kind of ratios you're looking at in the consumer side. But it's fun to do that because you say, okay, I built something great. How do I get it to more people? Oh, I can get this big model to show the smaller model what its output would have been and fine tune and distill and improve there. Of course, you may need to have, you know, open source models for that or open weight models because you can't do this all the time with the closed models. But that's, I think, the calculus, part of the calculus of being in the direct to consumer with things like AI DJ, AI playlist, some of our AI merchandising technologies as well, where you're doing this literally hundreds of millions of times per day for hundreds of millions of users.
Fabulous, thank you. Yeah, I think that we were talking earlier around as you sort of step up these magnitudes of scale, how the game changes completely. So being able to dig into those hyper-optimized points, being able to use smaller models or more constrained models so that they perform well on a particular task, that's a really interesting aspect. But how do you then, does it feel like there's an optimal point where you've got the maximum amount of functionality and the minimal amount of cost, or do you feel like it kind of comes and goes and you have to experiment a little?
So it definitely comes and goes, and you know, every month or every week there's a new model out there, so you need to maintain optionality. You don't want to be stuck with a model because you've built everything on just one type of backbone, and then there's a DeepSeek moment and you want to be able to try that out. So how do you set things up so that you can swap out models, you can A/B test models against each other? So we've talked a little bit about causality and A/B testing. Can you A/B test a cheaper model when it's available versus the current model and say, oh, I have better performance, similar latency, slightly lower cost, let me go for that. And so that's an important thing, and you need the right investments in infrastructure so that you can do these types of tests. You can, try different LLMs and see which ones are doing better. You can add more capabilities. You can increase costs with more parameters or more reasoning and say, is that worth it? Do I get an increased engagement, or is it just cosmetic and just more AI without real value? And so then you can say that's not worth the extra cost. And so there's definitely this aspect of scale, cost, and optionality, which I think is super important. You don't want to just be locked into one solution and then, there's a competitor and you can't even try it out and test it out.
Mm-hmm. And is that, how easy is that at your scale to be able to just try something and test something? Is that, or does it become even more constrained because there's so much that would actually hit that initial test that it becomes a test is almost a release in that regard?
So, testing is always expensive. It's not going to be zero cost. And you don't want to just test when you don't have a hypothesis or confidence ahead of time. So you don't want to just randomly test things. You sometimes need to do a little bit of offline and say, oh, this model offline, we can dark load the model before we actually test it. We can try offline evaluations and say, oh, on these types of metrics, it seems better before we spin up a whole A/B test, which also means we have, real traffic in front of real users, and you have to be careful because those models might have different failure points or different safety profiles, et cetera. So, but at some point in the day, you do have to test these things and see what happens with real users at scale, and then, you do a rollout. But A/B testing is really part of the Spotify culture, so that's really been a boon. We started with A/B testing for all sorts of, UX experiments and traditional machine learning. And so that was already really well established. So then when you have the AI revolution, generative AI everywhere, you want to make sure that you bring that same testing culture into the consumer AI experience as well.
Okay. Talking about the switch into generative AI, obviously in music and within the music streaming, we had an earlier conversation around it's relatively easy when it's text and people are using text because that tokenizes well with these models. But obviously the content that you deal with is not always that easy. Can you talk a little bit more about the different kinds of content that you deal with and the models and how they apply to those?
Sure, so that's a great question. We do have lots of kind of text from the transcripts of our podcasts and our audiobooks. So we have audiobooks on Spotify, we've got podcasts, and we've got music. Of course, I should have started with music because that's the big one. But at least for audiobooks and for podcasts, we can start with a transcript, and that tells you a lot about the content. And so we've been actually transcribing and understanding what's in the transcripts, whenever we have the rights to do so, let's say, and we can understand this is a humorous podcast about, philosophy of whatever, and then that gives us a way to target and recommend it to the right listeners. And then it's just language, let's say, so an LLM can help us with that problem. We've already been using LLMs to better understand, let's say, talk content. For music content, you could look at lyrics, but those are really not capturing as much about the content. And it turns out, deep learning and collaborative filtering techniques are really much better at music recommendation. You listen to this and then you listen to that, or user A likes songs 1 and 2, user B likes songs 2 and 3, so introduce song 3 to user A and introduce song 1 to user B. That's the vanilla collaborative filtering. But most recently, we've been seeing some techniques coming out of a bunch of research labs where you don't just feed large language models with text tokens. We've seen multimodal tokens. Everyone's heard of, vision LLMs with vision tokens, image tokens, and audio tokens. Well, it turns out you can also feed LLMs with catalog tokens. So what's in your content catalog, that could be tokenized. And you can also tokenize what your users are doing and what they're interested in, and that can also be turned into a language. Now you have to be smart about how you do this so you don't explode the vocabulary of the LLM, but then what you're basically saying is you see an intermingled text sequence with tracks and with other catalog items and with user actions, and you start to learn kind of the co-occurrence statistics. Just like LLMs are learning co-occurrence of words, you start to learn which things go well together and which go well with certain words. So then you can say, oh, I want a humorous podcast that's discussing, let's say, philosophy, and it knows what that means, and it knows what in your catalog actually contains that because it's seen it appear with those words in these types of data sets. So that's really where LLMs are going. They're not just text. Anything in principle could be tokenized. Well, not anything, but a lot more than just the text.
Excellent. One of the things that then becomes a challenge, right, is then, especially in an app like Spotify, where you've got really highly optimized UX and really highly optimized interactions, which have obviously been tuned to a paradigm where people are skipping or they're just moving on to the next track. But then if they want to start saying, okay, I want to listen to something that's a bit more humorous, or I want to listen to this track and I want something that's a little bit more smooth or a little bit more jazzy, then you have to start evolving your interaction mechanisms to be able to allow for that. And that in turn then can drive further complexity into these things. I mean, is that sort of how you see it's evolving?
Yeah, absolutely. So we're very much on that evolution, I would say, at Spotify. So of course, a long time ago, it was just here's your homepage and here's your search page. But now we launched about a year ago today AI playlisting, which is a conversational way of finding what to listen to. And so if you go into your library and you click plus and you say, I want an AI playlist, you start to have a text conversation with Spotify, and you can ask questions about what you're feeling, what you're looking for, and it'll talk back and ask you, okay, well, what about this and a little more of that? And then it'll actually go out and create a playlist based off of that conversation. So, our agents aren't just talking to you, then they're looking at the conversation and what went back and forth and saying, okay, now I know what to do, and then it goes out and agentically creates this AI playlist that you can push play and start listening to, or further edit, or come back to the conversation and say, oh, you've got too many instrumental tracks here, I want more vocals, and it'll say, okay, great. It'll go out and clean it up and come back with a different playlist. So that's already available. It's rolled out in the US and several other countries. So, you can try that, and that's opening up kind of a conversational UX in addition to the current navigational UX you're all familiar with. So you can scroll and click around your homepage. You can search, of course, which has been around for a long, long time, but search isn't a full conversation. But now with AI playlists, you can have a full conversation and say, I'm in the mood for, some instrumental music from the 1980s, all girl band only, and just, a little more energy so I can go for a jog. And it'll find 20 tracks that really fit that moment. And that wasn't possible without LLMs just recently. Yeah.
Oh, cool. Very cool. And you also mentioned, so obviously there's collaborative recommendation, the sort of standard cross match and between what people listen to. Do you see room for further collaboration? So now that you've got an agent to collaborate with, what about bringing more people into that conversation so you can start having collaborative playlists with other people?
So we do have some of these collaborative playlists. We've got this ability to blend your playlists with your friends' playlists and say, I want to listen to something that's a blend of both of our playlists. Here's a collaborative blend. And we've also offered that where you can blend your playlist with a playlist from a famous star. Like you can say, I want to blend my playlist with a Lady Gaga playlist, and there you go. It's a blended playlist. So we already offer that. We offer the ability to have social jam style listening where everybody can connect when they're in the same, let's say, Wi-Fi environment and start adding tracks and recommendations into kind of a joint listening session. And so that's already happening. At some point, you can imagine in the future, well, okay, your agent knows you, it recommends for you. You can start saying, hey, recommend something before the people who arrive show up. I'm going to have the following 5 friends over, and I'd like to create mood music for a dinner party I'm going to throw for all of us. and it should match the food for the dinner, because we're going to make it kind of a Latin-inspired kind of set of dishes. And so pick music that'll be good for all 5 guests and matching the food theme. And that could happen one day with kind of a multi-agent approach. But yeah, we're viewing this future where, we've heard some of this already being spoken by folks like Satya Nadella, for example. All apps will become agents. And so, your app that's in your pocket, well, maybe one day it'll be your music agent or your Spotify agent, and you'll say, oh, please talk to so-and-so's Spotify agent and so-and-so's calendar agent, and find a time for all of us to get together and have a dinner party. And so we can imagine that being something that happens in this multi-agent future. We're not quite there yet, but I'm just conjecturing. Yeah. But then that's the nice thing about agents and apps behaving like agents, as opposed to the classical navigational app we're used to.
Yeah, absolutely. I mean, I think the one bit that you mentioned there that's really interesting to me is this idea of an agent really understanding you and almost becoming your representative, as opposed to an agent that that's someone else owns that you just interact with. Mm-hmm. And so I think that's it's a potential game shift in terms of, once I feel like the agent belongs to me and it has my best interests at heart.
Yeah, I mean, that's really what we're hoping for. We notice when people talk about Spotify, they say it's my Spotify. They view it as their version of the product. It's their agent already in some ways. And so we want, this new AI technology to even further that kind of relationship and to make it feel like, hey, this is my AI agent, my app, my, experience, and I can ask it things and it'll get things done for me in a very personalized way and not in a generic way.
Yeah. And one of the other interesting challenges that I would see arising from that is the feedback that you get. I mean, you'll get a massive amount of feedback. One of the challenges that you probably already have to face is, how do you get signal out of all of that feedback?
Yeah, totally. So you do want to instrument your app and get a lot more signal and understand what's really working with users and log things and A/B test things as well. And so that's a great way to get the real value. I mean, at the end, AI is only useful in the value it shows and the jobs to be done that it does for real users. You can only go so far with a cool whiz-bang demo, and yes, it's great to have a demo everyone uses for a few minutes and it looks exciting, but it doesn't create that long-term value. So those types of things we have to be very careful of, that you want to test with real A/B tests and say, oh, we actually increased engagement, consumption, retention, and real human consumption of human creation, and that's kind of our driving North Star. So we're increasing how much humans are listening to other humans. That's the goal. Versus we just created a cool demo, and then you get excitement for a week, and then people move on to the next cool demo. And so that's when you're building AI for AI's sake, as opposed to a real value, a job to be done, a real need. We do user research. We look at how people are talking out in social media and say, oh, this is a frustration. People can't get this done. That's what you should be, focusing on in your next generative AI project, not just wowing people for a temporary, coolness moment, and then there's no real value afterwards.
Yeah, I love that. Users consuming content created by users. That we were talking about earlier, where there's so much challenge against AI is where it's taking away the creation part and then sort of just stepping into that. But that Spotify's focusing on really maximizing both the creation and the consumption is quite cool.
Yeah, so for example, we don't count how many minutes AI DJ talks to you as consumption. We don't say, oh great, you listen to AI DJ for 43 minutes today. That is a goose egg. How much did AI DJ increase your listening of real music and audiobooks and podcasts? And that's what we measure as the success of that product, let's say. And similarly for other AI experiences, AI playlists, we don't want you to just have the conversations in our AI playlisting feature, and then you try it, but you never really listen to the music. That was just AI time, and it's not the real value we're trying to deliver. So it's, yes, we need you to start there, but the ultimate goal is, did you listen to real music after that AI playlisting session?
Excellent, thank you.
perhaps as a last question for me, so as you having all of these capabilities, how is your team evolving? How the people and the skills that you've got within your teams, how are they evolving to both capitalize on this, but also to maximize what you can get out of these kind of technologies?
So the teams are always getting more sophisticated with the AI technologies we're adopting. That's happening across the board in the engineering, in research, in data science. Even the product managers and the designers all are using more AI tools and more of the latest AI models. We're using a lot of the protocols that are being created as well. So everyone's got to stay with the leading edge. And that's, I think, an exciting place to be because you're always keeping up and you're self-disrupting in a way. You don't want to be stuck on your old stack. So we're always evolving our technology stack. But we're also encouraging everyone to use AI tools for productivity and for understanding what's going on in a code base rather than going and tapping in a Jira on the shoulder or waiting hours for a code review. Can you automate that and accelerate the work because you can ask an AI assistant or you can get a code review done by AI with initial comments and unblock, oh, there's a comment here. This looks like this code may have some security issues. Things like that, I think, is really accelerating how work gets done day to day.
Excellent, thank you. Yeah, those were the majority of my questions. Any other areas you want to cover?
Just, again, I think there's a lot of great consumer products facing hundreds of millions of users today, so always eager to hear your questions on how they're working for you. So AI DJ, AI playlisting, some of the ways of explaining what the content's about is being done with AI. Of course, recommending what content you should see on your homepage is done with AI. But we're always eager to hear from everyone and user research. What are the things that are working and clicking, and getting that extra moment of discovery, which we care a lot about. It's not just listening more, but listening to new things more as well. And so I think that is, that's what we're always trying to ideate and come up with ways to even improve beyond what we already have.
Yeah, no, that's serendipitous discovery of something new and cool. Yeah. Always the best moment in a Spotify. Mm. Yeah. Any questions in the room? Yes, at the back. Sorry, let me bring you the mic.
Since Spotify is a consumer application, what is your biggest concern on cost on token to you?
Well, of course, cost is a concern because some of these AI models get quite expensive per token. If you're running at scale with hundreds of millions of users, using them, hours per day, that quickly adds up. Another concern with these AI models is safety. So we're very rigorous about what our AI models can say and do. And we pass them through safety models, which themselves are AI models, to make sure that they don't say something that would be considered offensive or unsafe or unsavory. And so that's another part of the cost. So you're basically running double costs whenever it's something facing the consumer, because unlike an employee using an AI tool, you have to make sure that you protect against the breadth of things that can happen in the outside world, which you can't do when you're controlling the AI in your company, let's say. So that's been another ongoing doubling of the cost as well there.
Just to kind of dig into that one for a sec. When you talk about protecting the consumer, does that lead to a lot of false negatives as well, where you're sort of overprotecting and therefore not making the optimal recommendation because you're trying to be too protective?
Well, there is always a ROC curve, if you want to think of it that way, where you want to make sure you don't get too many false negatives, but you also want to really be careful what you have at hundreds of millions of users scale, because all it takes is one, let's say, bad example to get blown up by social media and the press, and then people get the wrong impression of what you're doing. And so then we are quite careful on how we let the AI talk and what you can and can't say to the AI. And you also need to ring fence the AI agents. So the AI playlist, for example, the minute we launch that, everyone is trying at scale to make it do silly things and say silly things and take screenshots and show them to their friends. And people will use it to tell me how to make a dish, let's say, or tell me how to make something a weapon. I mean, of course, we don't want those types of things happening with our AI models. So we have these additional layers to filter out those types of interactions.
We notice the same thing with data scientists, by the way. So as soon as you give them an agent, the first thing they try and do is break it, which is always fun. You had another question over here.
Loud, sorry. You mentioned like discoverability being important, like showing your users new things. And when I talk to an LLM, like I know I can set the temperature, which is like how crazy it can go, how creative it can go. Maybe this feature already exists, but I'm in the UK, and so on my Spotify, I can't, tell it how different I want to see things. Like sometimes I get some of the songs I listen to all the time in a new playlist. Have you considered like giving that temperature control to the user in terms of just new things and discoverability of new music?
So that's a great question. We played with temperature, and you can kind of ask the LLM to be more kind of provocative in its outputs, but you can also just prompt it. And so if you talk to the AI playlist and you say, I want something new, I want to discover something very different, then through prompting, you'll get a similar behavior. So you can either do it that way or by dialing up the temperature. The temperature dialing can sometimes have unforeseen effects, though, because then if you dial up the temperature, all of a sudden the agentic flow may not work, because when you ask it, hey, I need to produce the following code or some kind of protocol or JSON output, and you dial up the temperature, suddenly it stops producing the appropriate output to actually execute what you said.
Yeah, I guess I meant more like, I haven't actually tried the chat. I don't know if we have it in the UK or I just haven't seen it. But I meant like on a holistic level as like a user, I'm still very just familiar with like, I like this song, create a new playlist from this song, but give me songs I haven't listened to before. Like on a user level, can I say, have you considered letting the users just be like, generally, I like, to discover more. I think in recommendations, it's like serendipity, or I think that might be the metric or something. Have you considered maybe just setting it on a holistic level instead of through the LLM?
So that would be interesting if you had like a way to dial it up for all the products. The way Spotify is built now, you've got a home page which actually has separate pieces and sections that are driven by different algorithms. You've got search, browse, you've got your playlists, very different types of playlists being built for different purposes, and you've got AI playlists. So all of these products have their own models and code. To just say dial up everything might be a little tricky, but certainly as we go more and more towards these types of conversational ways of finding content, so the AI playlisting, which I think is available in at least some places in the UK.
I'm definitely gonna look. Yeah, I didn't know it existed, so now I'm excited to try it.
Yeah, but you can definitely dial it up by saying, I want something serendipitous, and it'll use all those words and all that interaction, as well as your listening history and your actual real taste history to come up with a good playlist. So that's happening kind of as a mix of both classical recommendation techniques and this conversational LLM's suggestions.
Very cool.
Thank you very much. Whoa, it is loud. Tony, thank you very much. It seems like you and the team are focusing a lot on discoverability in terms of a key impact area for this technology. It would be great to hear, and I know you've touched on it a little bit in the conversation, is besides discoverability, where do you see the biggest areas of impact for agents and agentic technology?
Well, I think there is always more for the agents to do, and right now, yes, you can discover things, but you cannot ask the agent to go in through your library and organize it differently. And so you've got tons of playlists. One day I can imagine you could say, hey, I want my playlist to be all organized in a easier way to kind of consume. I've just built these in the moment. And so you can imagine more of this, not really discovering new songs, which is really the important value add that we bring, but also just better organizing your content and your consumption. And you can imagine the agent doing more for you. You can say, hey, I want to wake up at 7 in the morning and I want to hear this kind of music, but change it up every day. Some energetic music, from from something I've listened to in the past. Not necessarily a discovery of a new thing, but look at my history and kind of find something to wake me up with that I haven't listened to in a while. So all these types of tasks, jobs to be done that would be laborious for you to do, set up manually, I can imagine, would be valuable additions beyond just discovery.
Okay, yeah, no, that's very interesting. Thanks. I mean, maybe just a short follow-up question is, have you considered how you spoke about this world of agents and agents interacting with each other instead of apps? Have you considered how Spotify would, if it was sort of my agent, how that would interface? So for example, like, so waking up at a certain time might be, a process run by a different agent. Have you started considering things like that?
So I know these types of conversations are happening. We haven't really built anything that's a multi-agent across apps system yet, but I know that's where things are going. I mean, we're already hearing Google Gemini saying, "Hey, I have a meeting to get to. It's on my calendar. Shouldn't my calendar automatically set up an Uber so I can get there on time, and it should be waiting for me, 20 minutes before the meeting so I get there on time." So a lot of that, I think, is what's kind of happening with a lot of the agent ecosystem that companies are trending towards. And so, yes, this is already being ideated. It's not like it's ready to go and fully built out, but I do think your music and your audio listening will be part of that world. Yeah.
So 2 questions, hopefully quick. So my first question is about when you guys use natural like LLM enhanced like natural language search, or just to say search. How much of it in the guardrail, like safety and guardrail space, is that you could directly leverage the existing, like, because when you do like traditional search, you also have those, we also have those like guardrail whatsoever, right? How much of that is like reusable for the new kind of search? And for LLM specific search, any additional, like anything new in the guardrail or safety space that we should pay attention to? And my second question is about, like, at Spotify, do you guys use LLMs to build into the capacity of content, like say localization, like when you translate content or localize your offering, like say lyrics or other things, right? Like it's not just simple translation, there's like localized version of the culture and context. Is that something you guys already use to build into the customer facing products, and what kind of product is that? Because I'm not a Spotify user, unfortunately, because I work for Apple, so I use Apple Music.
Fair enough. I mean, I don't directly work on localization. We have an entire localization team that's separate, but I'm pretty sure they use the latest, greatest tools to localize. And to your point, it's not just a vanilla translation, but you have to capture, the local culture, et cetera, when you localize. So I don't know specifically what models are being used there, but we do have the latest, greatest for localization. And for your earlier question on search, we absolutely have safety layers in the search system. So when it gets more complicated, more conversational, you're not just searching for a track or something very deterministic, you will go through some safety layers, let's say, and those will sometimes change the output or sometimes restrict the output or make sure that whatever's being recommended is also safe content. So that's happening with an LLM style safety layer. The key thing is latency. People really want search to be super fast. They expect instant results. And so if your latency is too low or too slow, then you start to put friction in the search experience, which is, something people quickly notice and get frustrated with. So you have to be safe and fast.
Do we have time for one more? It's a little bit of a, I know you got your, 2 more, okay. A little bit of an off-the-wall question, or maybe not so off-the-wall. So do you have an analog strategy to cross over to the analog world? So can you pull in my Discogs catalog and figure out my preferences and go in and make recommendations for things I should buy on vinyl?
That's a very interesting question. I'd love to be able to look at your vinyl collection. Sounds like it's an impressive one, but I don't know how we'd go about that. I think maybe one day yeah, maybe taking pictures of things and uploading them or something like that would be cool. But yeah.
I have a feature for you.
All right. Yeah.
It's actually for me, but.
I have a quick question on future of it. Do you also have anything on your roadmap where you're thinking of using AI for content creation?
So we work with human creators, and so AI is being used by those human creators. And so we're not necessarily in the creation business. We're a distribution platform, and we're connecting creators and consumers. And so the creators are already using these tools, and we encourage that. I think every artist is getting more and more creative if they have access to these tools. And so I think that's how we view it, that the artists have new ways to make better art. We're here to get them discovered. Just like we want consumers to discover more, we want creators to be discovered.
Great. Well, thank you, Tone. That is great. We did good for time now, George? Fantastic.
Right.
Thank you.
Thank you. Great conversation.
Okay, and the last session of the day will be with Qualcomm. This is a very, very exciting partnership we're launching with Qualcomm around putting data science agents on the edge. So I know this, Sam Altman said that we're going to have, in countries of intelligence in the data center, but it may turn out that we have a lot of intelligence also on the edge. There's many applications in which you cannot wait for the latency is too long or the LLM is too slow, and you may want to have intelligence right there on the edge. So this conversation is going to be with Luis and myself around what it means for agents to be on the edge and the economic value they can create. So we couldn't be more excited about this partnership with Qualcomm. So today we're announcing it, and enjoy listening to how we're going to change the world together. So we are recording this for our conference. Hopefully we'll see you there in person next time. Our next conference is in London, and then we're going to have another one back in San Francisco. We'd love to see you in person, but for today, really grateful for your time. Very excited about what we could do together. And I just wanted to run through a bunch of questions that I think people will find fascinating, because I think it was, people kind of can imagine AI in a data center. And Sam Altman was talking about control uses in a data center. So people can kind of understand what that means just about. But when it comes to the edge, very few people have really thought about it. So I'm so excited to just help everybody kind of understand like this, incredible potential of edge computing that very few people are kind of, it hasn't quite hit the main spotlight yet, but it's coming.
Yeah, I agree. If you see what we're doing with Aramco now, it's kind of, just to give you order of magnitude, Darko, is $1 billion contract.
Yeah.
Where Aramco is putting most of the applications on the edge because they don't want to, for data privacy, and also they don't want to, they don't want to rely 100% on they might do this on their own, let's say, private edge or big data centers. They have enough money to do so, by the way. Money is not a problem. But there are applications that they need to run, instantly.
Yes.
And the things with vision, computing vision, and drone dispatch, and security stuff that you cannot wait for the data center response. And it's like a critical, mission critical things that is super important to have on premise, on site. So it's the opportunity is huge. Of course, the use case will drive the demand. I used to say that technology is an enabler. and then the use cases are the customers' pain points that we need to somehow solve the problems, right? So the technology for that, and also Darko, if you see the world today and how AI is evolving, the new UI are going to be the agents. Today, you get things like this smartphone, and then I type whatever I want. I put the parameters, and then I get a response. But tomorrow, and then I need to open up the apps. Like I open my WhatsApp, I open my Waze, and then or the Google for the searching. And but for the future, I might ask my agent. So think about that. I will not open the apps anymore. My agent will do so. We'll navigate through the apps and gonna choose the one that gets me the best response. So this is also, and by the way, this is all done in the edge for the most part, depending on the numbers of parameters and the size of the model. Okay. And then the cost, Darko, is imagine the cost today. We have some analysis. 70% is that 30% of the existing cost, 70% lower than the existing or the actual economics behind the AI. So, of course, we cannot ignore that most of the training still being doing by the big data centers. I don't have any doubt about it. We don't have very limited training on the edge. So, but inference for the most part is going to be in the edge. First of all, one is the cost. Second is the latency and the response time. And the third is even the privacy. Some companies, like big corporations, they don't want to exposure all the data through many different data centers. So they have to have a sort of control. We have seen even before AI, that we have seen this the move from the data center or the public to the private data center. The world like goes back and forth, everything to clouds, and then public, and now cloud, but private. So we strongly believe in this hybrid AI, where things are going to be everywhere. We're going to run models and inference in the data centers and also on the devices and the edge, on the edge computing side, meaning where you can put a small box or even your own smartphone, your PC, and that's the kind of world that we envision for the future.
Makes sense. And Luis, if we're going to double click on the specific use cases you see emerging first, obviously, doing compute on the edge and agents on the edge is, humongous opportunity. But if you think about the top 3 use cases that you think will emerge first, what do you think those would be for AI agents on the edge?
Very good. I give you. I have the ones on top of my mind. One is the security surveillance. Imagine that you have a plant. Imagine that you have any B2B business, and you have your site, and you have a camera. By the way, a dumb camera there, and then I can put my AI box. I can put the application, the model there. I can talk to the agent. Tell me if Darko is here.
Yeah.
I don't need to replace the cameras. I don't need to do anything else. I just put AI box. I run the application on the AI box. I connect the cameras through Ethernet, and that's it. And by the way, if I need to, if there is an area that nobody's supposed to be there, so alarm me, and then I can ask this by talking with my agent. So again, the agents are gonna, like I said before, the agents are gonna work and navigate through the applications. Regardless of application.
That makes a lot of sense. So that's a really interesting use case, kind of like talk to your video.
Another one, Darko, is for example, I need dispatching drones or dispatching vehicles. You know, I can say, you know, I have this alarm. Can you send a drone and check this out? You know, um, so you know, one is attached to the other. So once I identify the problem, I want to solve the problem. And if I don't solve the problem, I need another alternative, and then it's going to be another ask for my agent. You know, so there are a bunch of use cases today. I have one in agribusiness where you can, you know, agribusiness, rural areas, connectivity is something super complex. If I don't have connectivity, how can I run a model without an edge device running in the edge, right? So, and then I just talk to my agency to, you know, analyze the plants here or the seeds or how I should harvest an area based on the information that we have right now, you know. So we have a bunch of use case, Darko. And by the way, we as a company, as Qualcomm, we are working now in the blueprints and use case for the edge AI applications. Since payment, for example, things like very simple. Because I ask my agent to make a payment, like you know, I'm without connectivity, but you know, there is a sort of satellite or POS, and you know, with a palm reader or something, I can even without a credit card, I can make a payment. So it's I mean, there are, as I said, there are a lot of use cases that you know, we are exploring by verticals, because one is not 100% attached to the other, but we are exploring these with big companies, and Aramco is a big load that we have right now.
Oh, that's exciting. And Luis, are there any use cases where you need advanced like data analysis, things like streaming time series or something like that? I imagine you know, in oil and gas, like with Aramco, probably you get a lot of those. Could you maybe share, just for the audience, one example there on using agents to analyze data on the edge and derive insights on the fly? Yeah.
Yeah. By the way, everything in Aramco is by agent. So the UI, the user interface in Aramco are the agents. Okay. So I can do things like I'm in front of a machine at the Darko. I don't know how to fix that machine, and then I get my cell phone, and then I take a picture.
Yeah.
And then, you know, they recognize the machine is a given machine. And, you know, just brought me the manual, and then I can, and also, you know, what are the potential problems and things that I can fix. And by the way, all these things I do through my agent.
Mm-hmm.
Okay.
Yeah.
So,
yeah.
Yeah. So this is one case. So this, I mean, the computer vision and the agents will change the world. Okay. So the good thing that this partnership and the things that we are doing together at Darko with causaLens is is about how we get a lot of the data that they're going to get through the different sensors, different you know, processors, different than devices, a lot of raw data. I have my agent, and then I need to work on the, let's say, the potential outcomes, predict benefits, you know, and bring you know, different value added to the most part for the enterprise. Okay.
You know, and Luis, what's interesting for me about our partnership is that you know, in the past, before compute on the edge, before agents, you had no choice but to actually use other tools, you know, to kind of like get the data, like databases and like, you know, ETL tools. And there's like you know, loads of like 10 to 20 tools you need just to be able to do what we just discussed here. Well, now with our partnership, we can disintermediate all of that. Like, we don't need the database. We don't need the ETL tool. We don't need the modeling platform. All we need is, you know, our partnership, and we can get, you know, we are in business solving the toughest problems in industry, right? For me, that's like the most fascinating part that has only just become possible today. And for me, that's kind of why I get really excited here, is that there's so many use cases that were previously not possible. And I think this example you gave with taking the photo of the machine, having the manual in the agent and being able to say, what's wrong? It feels like, the right way to solve the problem. Previously, people would be like, okay, guys, let's like buy a database, put the data there for like months, and then hire a data science team. Let's then like buy a cloud, and let's then process it, and maybe then we'll deploy it. It's just not, it didn't feel right. But now I think we have this opportunity to make this this reality and unlock so much value.
Yeah, and by the way, if you think about it today, Darko, is of course we have a limited number of parameters and processing capacity, but we're just on the very first beginning. We're on the base steps of the technology, and there are a lot of to come over the next months and years. So we are fully convinced that edge will play an important role. Again, I do not ignore the data center. I do not ignore the learning. It's super important. But I think inference cost is going to be even so important as the use case and the technology itself, to really massify the use of AI, the agents.
That's right, Liz. And I think we're seeing kind of a big shift away from just training models, training compute towards inference compute. So that shift is very clear, and it's also possible to take a large model, distill it, and put it into a smaller model as well. So there's like a lot of cool new things one can do that were not possible even 6 months ago.
I fully agree. Much more to come. That's the nice part, Darko.
That's right, and for many use cases, that create a lot of value, and you mentioned a few of them, you don't actually even need the model to be, huge. Like you can do so much with some of the smaller models that would fit just perfectly on the edge, right?
Imagine the following, Darko. If I have the capacity to run the model in any device, and then I have my agent, regardless if I'm in the car, if I'm my iPhone or my Android or computer, I'm gonna have access to my agents because I can run the model everywhere and synchronize it. So that's, I think, is the new challenge for the industry, to be quite honest. I think the agents on the edge for me is gonna come. We have no doubt. Now is how I have a seamless experience through the multiple devices and multiple point of access with the same agents.
Right, that's interesting. And
actually,
actually, related to that, go for it.
No, sorry, we are working with a few OEMs. People that manufacture PCs and phones or even car. We have some Chinese like Xiaomi doing cars and and phones and tablets and PCs. They have their own hyper OS. They call it hyper OS, like an orchestrator. And I think the real fight is going to be who owns the agent. Who's going to be the agent? Because the agent is going to be the one navigating through everything else.
That's a really, it's a new ecosystem, right? So there's going to be a lot of turf fighting there. Luis, how do you see the interplay between the cloud, the data center, and the edge? Do you see, how do they coexist? How do they, what do we do on the cloud versus what do we do on the edge? Do you have any like general pointers for that?
Yeah, sure. Again, as I said, number one is training and inference, training data center, inference edge. Second is I need to be updated on the edge. So I need to keep getting the modules and the updates, like what is the weather today? What is the weather right now here in São Paulo? So I need someone to tell me how the weather is, right? To run my model. So they're gonna coexist It's going to be like a symbiosis on the data, the trainings, and also the datas on the data center, and then the inference on the edge. So they're going to coexist for sure. Again, depending on the applications and the model and what you want to do, cost is going to be more important or not, and then you do more on the edge versus more on the cloud, on the data center. Also, if you have connectivity or not, because sounds crazy, but rural areas, agribusiness, for example, here in Brazil, 1/3 of the economy, if I tell you that we don't have connectivity for the most part, and I need to bring AI, I need to bring productivity, I need to bring, other things. So I think they're going to coexist anyway. There is no, I'm better than you. There is more, what do you need?
Yeah, of course.
And the use case.
So Luis, obviously, we're just launching our partnership. We're extremely excited about what we can unlock today. If I was to ask you to make a prediction, 1 year from now, when we are here again in San Francisco next year, what do you think we would have achieved together?
I wanna, like we have discussed, I wanna run your agents, I mean, the way you can do your agent on the edge, and then you can process part of the capacity, like we said, the raw data on the data center. But we are gonna do a lot of the inference and then the conversations on the edge. So that's how we see things evolving, and that's why this partnership is super interesting and exciting, and we have a lot to do together, and I think the teams are committed to do it.
That's fantastic. Well, thank you so much for taking part today. I think it was really fascinating discussion. As I said, I think it's one of those topics that hasn't quite hit the spotlight yet, but I think it's coming very, very soon. So I'm sure the audience here will be very grateful for your thoughts and to get a head start on what is about to come into the spotlight. So really grateful for your time today. I hope to see you in person next time. And in the meantime, have a great travel. And we look forward to working with your team. And hopefully next year when we're here, we can show some pretty exciting demonstrations and case studies of what we've done together.
Very good, Darko. It's my pleasure. And again, let's shape the future.
Fantastic. Thank you, Luis.
Thank you.
A powerful way to close out a day at the edge of innovation. And that wraps up the 2025 AI for Data Science Conference. Thank you to all of our speakers, our in-person and live stream audiences, and the incredible team at causaLens for making today possible. Stay bold, stay curious, and we'll see you next time. And then also, everyone who is in person, feel free to join us for networking drinks in the lounge.